That's fine. But that's not a citation. A reference is not a citation. Okay, so if you want to use these words, go find a reference for what they mean, and then bring us back the citation of what they mean. Thank you.
So, can you tell me why relativity says that it would be equal if the sky was moving or the Earth was moving? Sure. So, the definition of citation, a quotation from a reference to a book, paper, or author. And the definition of reference, number 2, is the use of a source of information in order to ascertain something. So I'd say those are synonyms. You disagree?
No, not even close.
Awesome.
Dude, have you taken any collegiate or university level courses?
Yeah, I have, but why does that matter? Are we in college?
Have you done references and citations? Well, have you done references and citations?
I'm sorry, I didn't know that I was currently doing a college course on flat Earth in this Discord server. So can I not use synonyms? Is this like whoever said, what was it before? Someone said the
colloquial... A reference isn't a synonym for a citation, dude.
What was the the colloquial term for space. Someone used a colloquial term for space instead of using the actual physics term of space, right? So am I not...
Why should they use a physics terms?
Well, we're at a collegiate level to debate right now, aren't we?
There's no debate. You're just flailing.
So we're not. So I can just sort of like give the references a wiki article that has a list of the actual copies of the scientific paper. I can do that, can't I?
Right. That's not a citation, though, friend. That's the difference. You're offering references while asking for citations.
To reference something is to point at some source of information, like a...
Right, that's not the same as citing it. That's not the same as citing it.
I can cite a reference, and I can reference a citation. Are those two sentences equal?
No, they're not.
So if I cite a reference, if I say, my reference for this is my friend Jason X, who this is his phone number. And if I reference a citation, I say, my citation is the one written by Jason something, here's his phone number. Is that not equal? This is just...
No, because now you're mixing categories.
Do you guys have any reason why Michelson-Pierce scale didn't show the Earth was in motion?
Oh, yeah, because they had to apply a mathematical transform to fit their bias in order to get the conclusion that they wanted.
My boy just realized he goofed up and tried to run away from his own little example.
No, I'm just tired of the semantics. It's pathetic.
It's not about semantics, dude. It's about earlier you were asked to cite something that you offered as a reference, and you just told people to just read it. And I was just pointing that out, that you're a hypocrite.
How? I read out the results.
Okay, look, fair enough. Okay, maybe you're not a hypocrite. Maybe you just are ignorantly think that references and citations are the same thing. We'll forgive you.
You haven't given an argument why they're different. You've just said, are you doing a course? And I said no. Do you want me to read out dictionary definitions again?
Dude. Okay, for example, if he asks you for a specific piece of information about something, right? And you say, I'll give you the wiki in total.
Yes.
You're referencing the wiki. Now, if he says, I want this specific piece of information, you go to the wiki, pull out the citation, give him the citation from the reference that has a specific piece of information. Those are entirely two different things. They're not synonyms.
You think that citation has some different meaning.
Dude, I just explained it to you. Very simply.
From or reference to a book, paper, or author. That's for citation. For reference, the use of a source or information in order to ascertain something. Provide a book or article with citations of sources.
Oh my goodness, dude. Dude, you're wrong. You're stupid. You forgot the word specific.
To specific. No, it says or a specific reference.
Oh, a specific reference.
Yeah.
Not a general reference.
Citation, definition.
Holy fuck, bro.
Quotation from or reference to a book. So that's the noun definition for citation.
Yes, and where's that
This
in?
is used in the definition of citation. You understand that, right?
Dude,
Quotation from.
if you're asked for a citation, yeah, you need a citation is a specific.
You guys have argument for flat Earth.
Yeah, you already conceded down is down, and water's flat and level. Therefore, the Earth is flat. Welcome.
Tower bridges show that Earth is not flat and level.
How?
Quarry tanks show Earth is not flat and level.
No, wrong. You failed to provide the citation that you were asked for about the tow tanks, how they specifically measured curvature.
No, string line.
You failed to provide the citation, friend.
No, you just didn't like the citation.
No, you didn't have a citation. You just generally said the term string line, just as you did again now.
And?
Watch. Ask me how, just ask me in the reverse. I want to play role play so you can see how stupid it is.
Yeah, sure.
Ask me how to prove, or what proof I have that the Earth is flat. Ask me that.
What proof do you have the Earth is flat?
Lasers.
Cool. Do you have a reference for someone claiming that lasers show the Earth is flat?
I do.
Awesome.
I have an 120-page PDF and an accompanying documentary of the methodologies and the practical tests that they did. And I also have a citation from their document that says the WGS 84 model is not found in the field.
Great. Link that and I will read it. See how that works?
Okay, perfect. Now, actually, my friends are going to link it because I'm going to speak. So, links, FE Core, for my friends who are using the bot, and then exclamation point videos laser short, exclamation point videos laser long. The short version is a condensed version that you can watch, and then the long version is the long version, obviously, that you can watch when you have more time. Now, I'm going to give you the practical methodology because I'm capable of... Hold on, friend.
I wanted to. Oh no, it's a PDF. Okay, we're all good.
Oh my fuck, dude! Did I not tell you what was coming down the pike? I said a PDF.
But then you spoke about long and short videos, and I wanted the PDF.
Yeah.
I don't know if that was being linked as well, but someone linked a PDF.
Yeah, fair.
I do.
No, all right, good.
Where?
Oh yeah, it's my turn to calm down, bro. Were you not on calm when you began? The answer is yes. So fair is fair. Yeah, anyway, let's move on. Let's move on. When you asked for a citation of the methodology that they used with the string to prove curvature over the distance, you weren't able to provide it. You didn't cite from the text, and you didn't articulate the methodology. You didn't cite it from the text, nor did you articulate the methodology. But I'll tell you the methodology from this laser test, right? If you want to listen, I'll tell it to you. But you can also validate it from the document. So this is actually multiple tests, culminating in the final biggest test of 25-mile sample size over water, right? So there's 14 or 17, I can't remember correctly. But the longest one they shot was 25 miles. So what they did is they set up what's generally known as a laser transit, right, methodology, which is you have a laser, you level the laser, you shoot the laser across, and then you use what's called a storyboard or a receiver that's at the same relative height, and then when it hits, you see where the laser hits, and then you can tell how off it is. We use this in construction all the time to level foundations, excavate, all kinds of stuff. Very practical methodology, very simple. So if you have the laser set up on one side, right, about 2 meters, 6 feet off the ground, and on the other side you have the story or the target, about the same, 2 meters, 6 feet, right? The globe Earth predicts a differential between the off angle that the laser should continue into the sky if it's perfectly level, and the target at that distance to be 90 meters, right? So in other words, the big hump of Earth curve water and the level laser, right, can't shoot through the hump of Earth curve water, so it shouldn't hit the target. It should go over the target by 90 meters. Now, when they set this up, right? They took into account the ambient conditions. They took into account the millirad divergence of their laser. They created, which is in the documentary, a very accurate aiming device and leveling system. And if you watch it, you'll see how precise it was. Very precise.
Type of laser,
And-
was it?
Well, you'll have to look into there. It's a big old laser. A laser sufficient to shoot 25 miles with a very limited millirad divergence.
Yep, I read that.
So sufficient to the task. And they might talk about the type of laser, because they actually had two. I think the first one failed or they destroyed it. But anyway, they talk about that in the thing. And they give the specs for it. So they did the test.
So it doesn't matter. Refraction wasn't accounted for.
Says who?
Them. As light travels in a straight line through a homogeneous medium, light angles due to different refraction indexes in a non-homogeneous atmosphere. We calculate direction and amount of refraction to show how much laser beam deviation affects the measurement outcome. In a non-homogeneous atmosphere where the index of refraction increases with height, rays of sufficient small initial elevation angle of refraction.
Holy crap, dude.
Is proportional to the rate of increase of the bi-directional index of refraction.
Yeah, you just said they didn't account for refraction, and then they went on to say we accounted for refraction in the very text you just quoted from.
Yeah, but they accounted for it wrong. And well, actually, they didn't. So they're saying that it's a homogeneous through a homogeneous medium. We calculate direction amount of refraction in a non-homogeneous atmosphere with the index of refraction. Blah blah blah. This curvature is proportional to the rate of increase of the bidirectional index of refraction.
Yeah. Anyway, so they set it up. They set it up, and the laser hit the target. Okay. Now, you may claim they didn't account for this, they didn't account for that. That's fine. But at least they have a practical example of their methodology.
Here we go. This is because I've read through this before, actually. Here's the problem. So the lake was partially frozen, therefore walking along the beam on the ice or using a boat was not possible. There's no data on the ambient conditions along the laser beam were available. We measured the conditions at the measuring.
Yeah, which site, which shot is this? Which shot are they talking about?
I don't know. I'm just reading out of the text document for refraction conditions, the PDF.
Which test? Which test was it? What location?
Point of laser beam.
I told you there was about 14 or 17 different ones, dude. You can't just pick one at random.
Well, this is their heading for refraction conditions.
Oh my goodness, dude.
So they said when they measured refraction between the
which location? Which location?
Why does that matter?
Maybe because, listen, friend, maybe because over time and at each location they learned things and improved their methodology.
Then why wouldn't they add that in under the refraction category or subheading?
Dude, how many different shots were there? How many different conclusions?
Right now.
I don't know, dude. How about you read the whole entire thing? How about that?
Yeah, I thought so. You'd run away from this discussion because you don't actually...
I'm not running away from it. I'm asking you specifics about the thing, and you're not giving them.
Bruh.
Now, by the way, in the final 25-mile shot...
Temperature was 2 degrees, the air at night was 3 degrees. Humidity is always high the closer you are to the lake surface, which indicates a lower refractive index. They just assumed a low refractive index. They didn't actually measure one. The ambient conditions showed that the refractive index...
Yeah, which location?
...was the two sides of the lake. So they didn't measure the difference across the lake. They just measured one side of the lake, the other side of the lake, and said, yeah, good enough. Am I wrong?
Yeah, maybe at that site that's what they did. But which site are you talking about?
The refractive, measurement number 1.
Measurement number 1.
Find the actual spots where like,
oh my god, dude.
Balance on Villegas observation points. And
is it observation
laser position?
Yeah, is location number 1 the one where they state that the WGS-84 model hasn't been sort of upheld?
No, that's just their first one they did, dude.
Well, that
anyway.
then. if
He won't even make it onto the rest, dude. He's just going to look at number one, say they didn't account for refraction. Refraction curves light.
It was still at 0 degrees, and the air of the
That's
light
the
was
point,
down
right?
to 11, minus 11 above the air. Air temperature at the time of the measurement was minus 6. The ambient conditions
So
showed
we're
the
just gonna carry on with this. Yeah,
refractive
I'm gonna talk through
indexes
you
were about
because
the
I'm gonna-
same at the two sides of the lake. So they're just on the same thing, two sides of the lake.
Yeah, so the point I was trying to make is that if it's the first measurement that doesn't state that the WGS84 model is invalid, then what they did there isn't relevant to this argument. Cricket.
My argument was their methodology was incorrect because they didn't
Right. So
measure the refraction
which
across the
location-
lake. They measured it from 2 points, the start and the finish. And if the beam was to
location one,
curve,
yeah?
it would curve between the start and the finish, not starting at the start and ending
Fantastic.
at the
So
finish.
is that location one?
Yeah, and location 2,
Okay,
they use
so
the
in
exact same
location
methodology.
Is location one the let's just call it
Okay, stop
experiment?
for a second and listen to what I'm saying.
No, I'm
I
not
just
gonna
read
stop
location 2, and they use
You're
the exact same
talking
methodology.
through me. I'm not going to stop talking, right? So the issue is that if they are not using location one as the quote-unquote evidence for the WGS84 model being invalid, then it's a waste of time to analyse the methodology there.
The second one did the same thing. All of their measurements, they just measured the temperature at the start and at the finish. They didn't measure the refraction between them. Do you understand that, Crypto? Do you understand what I just said to you?
Is location 2 being used to invalidate the WGS84 model?
It doesn't matter because they use the same.
Fantastic.
They
use the same.
They use the same way of calculating refraction in all of their experiments.
The conversation. You're just wasting everyone's time.
What did I just say to you, mate?
AI, I heard what you said, bro. It's irrelevant. AI, can you tell me which location was actually used in this argument in terms of the WGS84 model, and then maybe we can read that.
Oh man, the only one I was talking about was IDSIL, the biggest one.
Fantastic.
Calculation of third measure.
So we're going to look at the methodology there, or we're just going to ignore that?
Condition shows the refractive indexes were about the same at the two sides of the lake. The same methodology. It's a failure because of that methodology.
Which location was that?
No, I mean not really, dude. You can interpolate the lake, bro.
Lake Isle or whatever that is.
Unless you think that there's going to be a dramatic change in the middle.
Yeah, of course there will.
Okay, let's say that's true.
The middle is over water. Do you understand that? The start and the finish are both land, and the middle is water.
No, they're not just like in the middle of land, dude. They're on the coast.
You idiot. They're both on land, and the beam goes across water. Those are two completely different sets of air they're going to be going through. One's going to have
a frozen
constant...
lake?
Sorry?
Isn't it a frozen lake?
Partially frozen lake, but you understand that
right, so frozen water,
exothermic and endothermic effects.
Dude, do you really think that you're just going to use 4-syllable words and that's going to frighten anyone here?
You know what exothermic and endothermic means?
The frozen nature. So the frozen nature of the lake obviously changes the refractive properties of the air above the lake, doesn't it?
It does, and they should have measured that, but they didn't.
Wonderful. Yeah, but obviously you're saying it's water, which is being dishonest because it's partially frozen.
I'm sorry.
Also, we don't have the burden of proof.
And wrong. I'm sorry.
Also, we don't really have the burden of proof there because your side has never proven that the light is bending around the globe to make it appear flat.
That's true, brother.
That would happen.
What the? Yeah, you do.
We say refraction would change it so that any observation we can have a certain deviation. If you take refraction into account, it will always fit the globe.
Yes, dude. Did you not just hear the words that were coming out of your mouth? Hold on, friends. What did he just say? He said, no matter what observation you make, it will always fit the globe. Wow, very scientific. You just ceded that any observation that supersedes the globe geometry, you just add the word refraction and it magically cures it.
Yeah, sure. It's like when will water boil? If you add pressure, suddenly it'll change, won't it?
Yeah, sure. Yeah, sure. We have an unfalsifiable tautology that begs the question and inputs values up into 60 billion mile radius to account for refraction.
What question am I begging? What question am I begging?
Listen instead of talk. Maybe you would know.
What question am I begging?
The globe in the first instance, brother.
No, we've measured it.
How?
I just told you there's tow tanks, there's tower bridges.
No, stop right there, friend. Stop right there. Stop right there. Stop right there. The tow tanks, you didn't give us the methodology of measurement. The towers, you didn't give us the methodology of measurement. You just claimed them as a positive assertion. And then when I asked you what's the methodology, you simply said the word line. Fishing line, I think, was the actual word.
You're choosing to ignore all the times I read it out and just focus on the one time where I said string line.
No, I listened to you read it out, and that wasn't a sufficient methodology to see that the entire bar was curved, dude. It was segmented. You didn't even explain to the person who asked you. You didn't even explain to the person who asked you how they did it.
As you guys like to make Globers do, you're willing to concede that I didn't just say line in all instances. Can you concede that?
No, I'm saying when I asked you.
So you're not going to concede something that you just admitted to?
Dude, when I asked you, it was correct. You just said line. Previously, you read something out about a line. Listen. Previously, which I already had just said, you read out something about a line. You were asked to clarify how it was done over the entire thing. You were asked to point to it, and you didn't.
I didn't what? What was I meant to point to?
How they applied the fishing line to prove that the entire structure was curved.
I wrote it out a couple of times. They put it at 2 points with a microscope pointing at the fishing line.
Yeah. Right.
Yeah.
And what did they do then?
A reference that they could then move the beam so that it had the correct amount of curvature according to that reference.
Okay, hold on, friend. Pay attention now. If you pull a line taut without the catenary curve in existence, you'd have a straight line.
Yes.
Right? So unless you have a benchmark, all you have a straight line. So if you then...
You can have a calculation of the amount of curvature that you want in that thing according to the reference.
Bingo. I want everyone to stop right there and notice how if you take a straight line and just calculate how much curve should be there, you can then make the claim that curve exists and that you've measured it. Slow clap. Slow clap, friend.
They did what? Correctly.
No, friend, stop. You're assuming the water's curved, bro. You have flat water.
And then you
hold on.
The thing that you're making.
Right, so my friend, hold on. The previous guy who you asked 30 minutes ago, he critiqued you that you just assumed the water's curved, put the line parallel to the water, and then put the beam parallel to the line that's parallel to the water and assume that all three are curved, and then call that a measurement. That's what you did, brother.
No, I never said the line was curved. Remember catenary effect? I said specifically it wasn't curved. I read that out to you multiple times.
Okay, so let's be clear. If the line isn't curved and you parallel the metal to it and it's parallel to the water, then that means the water's not curved, and that means that the rail is not curved.
A reference didn't parallel it. You ever used a straight line before?
I build things, brother.
Great. So I built a fence not long ago, okay? And my fence, it was a picket fence, and that picket fence went up and down, up and down.
Correct.
Do. Right. So
absolutely.
I did a line, and then I referenced the amount that the middle picket would be up off this straight line. And from there, I could reference out the curve.
Perfect. So where did they do that in your example?
I just read it to you. They had a microscope that pointed at the string line and at the beam thing, and then they calculated how much they'd have to have of curve on that beam to match the water on an earth of a given radius. And they referenced the distance between the string line and the beam on the
right. What was the length of the string line? I
don't know.
Well, that done fucks it up, doesn't it, brother?
No, a gap in knowledge doesn't mean that the whole thing can be thrown out.
No, I'm saying
That's actually-
if the string line isn't known, right,
God, what's the name?
and it's not sufficient to the task, and then you give us the answer that's not sufficient, that's going to screw up your argument. So how about you go get us that information?
Well,
How does that
he
spread the
also
argument?
he also just
knowledge
justified
doesn't
all
mean
of the
that the
laser
rest of knowledge
laser
can be thrown
measurement
out.
he just got shown because like a gap in knowledge does not disqualify the argument. So apparently he just justified all of the laser measurement. Thank you very much.
What did I justify?
You said there was if you have a gap in your knowledge that doesn't disqualify it, and you said that we don't know the exact temperature over the water in between the measurements of the lasers, and so according to your logic, that still stands.
That is almost a smart argument. It's close, but not quite there. So the problem is that I have a gap in my knowledge. That doesn't mean that they have a gap in their knowledge. So the people that actually built the tow tank didn't have the gap in knowledge. I just have a gap in my knowledge.
Right, so you haven't provided the methodology.
The experiment had a gap in their knowledge. The people doing the experiment, the laser test, had a gap in their knowledge, which does invalidate their experiment because they didn't account.
Not really. It doesn't really. You're assuming that if there's a massive temperature differential, then the light's going to be able to travel around the ball and hit the target.
Yeah, it is. When we account refraction in.
Yeah, no, you don't have the conditions required when you measure the temperature on both ends.
Sorry, sir.
Dude, I don't know why it's so hard to get, like...
We can get the conditions in the middle? Is that what you think?
I think you should get us the knowledge that you're gapping on, because that would be the thing that would validate your entire claim.
Yeah,
No,
like the length.
I don't need this to be 100% fundamental.
No, it's not, dude. Right now, it's an assertion.
A reference to a piece of evidence.
Look, listen, friend. Guys calculating the curve they should expect, and then forcing that expected calculation into a piece of metal doesn't prove the Earth is curved.
Of course it does. The tow tank works. So that's
holy frick, dude. No, let's be clear. Let's be clear, dude.
That's a logical fallacy, dude.
No, it's not. What logical fallacy is it?
It's called appeal to pragmatism. It works, therefore it's true.
I haven't heard that. Appeal to pragmatism.
Right. It also assumes...
You haven't even heard what your own argument is.
Correct. It also assumes that the variable in difference that they needed to account for would have made the object in question unusable had they not accounted for it. But when you look at the tolerances necessary in those machines, and you look at what the alleged curvature is over that distance, it's negligible, inconsequential, irrelevant.
So it doesn't seem to be that it's a pragmatic fallacy.
It is. You said it works, therefore the reasoning is correct. That was your claim that you just said to try to rebut me.
Well, no, it works because it physically exists. So a pragmatic fallacy would be something...
My truck... Oh, dude, my truck works. My truck works. Right? My truck works.
I believe X is true. Believing in X results in practical benefit... results in practical...
No, dude.
Therefore, X is true.
Dude, no, that's not how it works. Here, let's put it properly. Hold on.
Consult my horoscope, things always go wrong. So it seems like when there's actually like a physical thing, then the appeal to pragmatism is...
Dude, you're trying to say the tow tank works, therefore the Earth is curved. You're not trying to say the tow tank works.
Let me give an appropriate analogy. Epicycles work, therefore they're true. Epicycles work, therefore they're true. That's the actual physical situation. Epicycles, yeah.
What are they?
It's a Ptolemaic model of orbits.
Do they work?
Yeah, they work. Yeah, they work great. They work better than frickin' Newton's model or Kepler's model. Yeah.
Can you reference that?
Oh, sure can.
How do you spell it?
Never heard of epicycles? Jesus Christ, man.
No, I haven't.
Some elementary shit.
Do you speak any English?
Epicycle model.
Yeah, they use them in a planetarium when you go there. When you go to a planetarium, they project the planets and the stars on the ceiling, on the dome ceiling. They use epicycles. They don't use the heliocentric model to model. Just because you have a model that works doesn't make the model physically real or have some ultimate reality there. This shit is well known. It's not even an issue.
What do you mean by works? Do you mean as if we model something out, we get a result, or do you mean as
Yeah, and you got a result. Yeah,
build things based on it or measure things based on it?
Yeah, that's called engineering. Yeah, it's awesome.
Yeah, what it's called is predictive evidence.
Okay, so
what they did is they predicted that the water would curve. They predicted in order to get their rail to match the water, they would have to make their rail curve. They then predicted that a string line would have to deviate at certain points by X amount in order to fit that curve prediction. And then it was all true. That's called science, buddy.
No. First of all, that's not called
So
science.
I'm not saying anywhere that
that all would be like post-dictions. Those are all like post-dictions. Because they had to alter the string. I'm reading it right now.
No.
They had to adjust the string until it so-called aligned.
What part? Where's that?
I'm going to read it. A 0.33 millimeter dynamine fishing line was attached to one bespoke winch at each tail end. The line has a breaking point of about, that sounds precise, about 25 kilograms, and very little stretching. Oh, that's scientific too, man. Very little stretching. It's not even like they have two things here that they didn't even quantify.
Sorry, you haven't validated your claim, mate. Go back to your claim.
Listen, I'm going to keep going. I'm going to keep going. Don't worry, man. There's more here. So, but I'm just saying, this does not sound like precision. Okay. Anyway, which allowed it to be pulled very tight and reduce the catenary effectively. A microscope was mounted on the rail to look down at the line and perform the adjustment with high precision. Right, so they adjusted the string until they got it to match really where they wanted.
That's really sad.
So this is your repeated thing I've been listening to over and over again. When you get cornered in this box, you start talking about us and how our argument is and how sad our argument is, and you start talking about us. The way we're talking, the way we're arguing with you. Shut the fuck up. You're here for round 3 to get knocked out, dude. This is like, Hearns versus Haggard. There was never fight 2 and 3.
Where'd they move the string?
Anyway, this is not a precision measurement. This is garbage, dude. Garbage.
Yeah, I'm referencing some experts that built something according to the curvature of the Earth and it worked. What's wrong with that?
Yeah.
Are they lying? Do you think they're lying?
I think it's confirmation bias. That's what I think.
Okay, so they specifically machined and came up with a system to make the rail curve to fit what they thought the water would do, and it was correct. And you think that's confirmation bias? How does that work?
Yes, I do.
So if I was to think something like no, like if you just use like a base iron to make a camshaft, that'll be fine. Like it's great. I believe that. Someone told me it had worked before because I used it in an old steam engine once. And then you do it and it fails because it's not the correct metal to use.
Yeah, and how is that analogous to this?
So confirmation bias failed in the practical, didn't it?
Yeah, because that's why engineering, you do things by trial and error.
No, you
right. So things are manufactured all the time that fail, break.
Engineering is doing things by trial.
It is.
That's the dumbest thing I've heard. Honestly.
Well, then you've never actually made anything. Have you ever made anything in a manufacturing process? Have you ever worked in any manufacturing environment?
Yeah, I've worked in a couple of factories. They're shitty jobs, but yeah.
No, like an actual manufacturing environment where they actually engineer, design, and make the product, and then have samples, and then the samples are gone through tests, and then you have the production line, and you start making it in production, and then you have to have quality control because not even that is a perfect process. It's called trial and error. Yeah. So you start with an idea, right? You maybe apply some models. And then you engineer some prototypes. Some of those prototypes will work. Some of them won't. Right? So if they could just do it by equations, then they should just be able to fill out the equations, do the math, start pumping out the products without ever testing them.
The one I worked in made fire-resistant suits for firemen. Right? Mm-hmm. And well, it was for firemen working with the army, so it was like armed personnel, fire-resistant suits. And what they did is they got the known tolerances for the fire-retarding capabilities of certain fabrics, and then they got their heat sink capabilities of other fabrics. Okay,
Yeah.
they added all that in with the dimensions of a human being, and then they modeled that out so that any stitching would be covered. And then everything was cut, everything was manufactured, and they tested it at the end to make sure that everything they'd done was correct. But everything they'd done was correct. They then updated it depending on user needs. But that fabric had known properties, and they
How did they know the properties?
That they
Did they use equations, or did they test the fabric? So they got the fabric secondhand from somebody.
Someone else did.
Exactly. So they got it from somewhere in that place that manufactured the fabric.
Steel, do you? The manufacturer tests the steel to make sure the grade is correct and then sends it to you.
Yeah, they have test samples. They test samples, right? So they manufacture fabric samples.
Engineers buy things of known properties. They don't test everything.
Yeah, it's known because they tested it to trial and error and figured that stuff out.
Yeah, a long time ago, and now they're known properties, so engineers can make things using those known properties, like the engineers.
Yeah, so they're just using trial and error.
They knew the known properties of that fishing line before they started.
Not within any certainty, obviously.
Yep.
About 25 kilograms with quote unquote very little stretching. Not the stretching was not quantified. The break point wasn't actually quantified.
And
it could listen.
And
the catenary curve that they calculated existed might not have existed.
How do you know that? You're just coming up with that if they've had some monumental failure.
Because you think this is a precision, some sort of precision. Listen, because you think this is a precision measurement of curvature.
The precision in that document. How do you know they didn't have the precise properties of that string line and just vaguely referenced it because they couldn't be bothered going and looking it up again?
How do you know these people weren't fucking aliens from Mars and didn't just fucking throw a bunch of random words on the pick of paper? I mean, come on, dude.
We've never seen aliens in existence, but we've seen people in existence. We've seen engineers in existence. We've seen the properties of certain string lines in existence.
We don't see curved bodies of water in existence.
We've seen that when engineers calculate as much stuff as possible and it all works, then it's reasonable to assume these engineers are competent, aren't they?
We don't see curved bodies of water in existence, so no, that's stupid.
Where, heretic, where? Is that all you got?
You're just assuming shit, right? You're just assuming shit, which is par for the course.
Yeah,
it doesn't shock me.
Induction. I know it's scary to you guys.
Yeah. Inference and induction. Yeah, great. Affirming the consequence.
Oh my God. Can you say it again? Inference and induction?
Yeah, inference and induction. Yeah.
What's the inference?
Inductive logic is hinged on making inferences from observations. Is that not true? Is that not a true statement? Is that not a true statement? Yes or no?
Did you say inferences?
Yeah, dude. How come every time, see, the problem? One of your problems is you talk too much.
You said properly.
You talk too much. Do you know how many times you have to say I didn't hear you because you're fucking flapping your gums?
We're on Discord, mate.
Yeah, because you can't listen and talk at the same time. That's why you can't hear people.
Induction also doesn't lead to concrete conclusions. It only leads to strong or weak, potentials.
Well, he didn't even do that. He just assumed his conclusion in the first place.
Well, no, I didn't. I gave.
Yeah, you did.
So what I have is a hypothesis. And
you already admitted
my hypothesis is either
you assumed a curved water level, you matched some railings to the curved water level that you assumed, and then went, good, it's all curved. That's all you fucking did.
No, I didn't. What they did was they made the railing.
You're right. I misspoke. You didn't do that. That's what you think someone else did.
So we're at the point now of just muting me all the time? We're finally done? Do you want me to just go now? Are we done?
You can do whatever you want.
I can leave if you want. If you're just going to mute me anytime I'm halfway through a sentence.
Well, you can sit here and cry or you can leave. I don't care.
We just told you that, basically that you're over talking. I tried to tell you what the problem was, why it's not a good thing. Because it means you're not listening, right? And we're just wasting our fucking time, which I'd rather not do, right? So
no, I was listening. I just think you're wrong. The reason I couldn't hear some people is because some people are low. So I'm trying to figure out who is talking, whose sound is low, so that I can turn them up so I can hear them better next time. Make sense?
Anyways, Linda, feel free to be a beta and leave if you want, but that wasn't what we were trying to do here.
Why would I be a beta if I left?
And you still haven't proven curvature or anything else. All the stuff you said is crap.
Why do you use the word prove?
I can't even
inductive
read
evidence, which can never prove anything. It's called the problem of induction.
Trying to figure out why they need to compensate for curvature for this design.
Why
the rails must be aligned vertically to follow the curvature of the Earth. Vertically?
Vertically?
Yeah, the rails must be aligned vertically to follow the curvature of the Earth. Horizontally and in roll in Southampton, Saginaw, oriented a tank of 138 meters.
Yes, that's talking about
is about 0.6 millimeters.
That's talking about the rail, in this case, has little like jacks under it to move it up and down before they set it. So they have to be aligned vertically. Those jacks have to be aligned vertically so that the horizontal lines up with the horizontal curve of the water. What's wrong with that?
Doesn't seem necessary for what they're doing.
Why? They're trying to do
I'm reading it,
measurements of different hull shapes.
Well, do you know what uncertainty and precision is?
Yes.
Okay.
Uncertainty is an unknown, and precision is to the highest degree of measured known. So for this tow tank, they need to know if there's a deviation in the railing, because that deviation in the railing would cause the hull of whatever thing they're testing to push further down onto the water, causing more drag and changing the results, or to go higher up over the water, which would reduce drag and ruin the results.
Okay, and if they didn't do it right, what would happen? Let's say they did all this process and they did something wrong and they didn't know about it and it's not in this document. What would happen?
What would happen would be that the boat, when they move it along the railing, would experience more drag in some spots than other spots, which would mean they would.
You mean so they're trying to model drag? So this is a tank that's trying to model drag,
amongst other things. Yeah.
I'm trying to figure out what the even purpose is. It just seems like just some nonsense.
I can answer the question. It's very simple.
And you get a hull design of that boat.
You're saying
hull design will go faster than others.
Brother, you're saying the same thing, so we're going to break it down to simplicity. All you're saying is that the rails must be parallel to the water surface. So this entire procedure is to make the rail parallel to the water.
Yep.
Yeah. That's
only the of Earth curvature is in calculations. Thank you.
That's my case. Again, because you were too upset and you cut out.
Well,
or they measured the curvature of the water level that they assumed.
All right, I'll say it
again while he was talking. So let me translate in normal speak.
Oh, I wasn't normal speak talking, but I'm talking while you were talking because it's kind of sad to start off like that. So, Arden, do you want to just say what you said again? Because I couldn't hear you because you got too upset.
Yes.
See, once again, talking about how we're talking, you're being exposed. You're a chump, dude. You're just a chump. If you're going to talk about us, I'm going to talk about you. You're a chump.
Anyway, I'll validate my position, which is this. I'm driving a truck, which has axles, which make noise. And I have auditory feedback in my ears to my voice, where I increase the amplitude of my voice based on how much roid noise. Right, it's not that I'm upset. So again, you failed. But anyway, I'll say it very calmly. Yeah, perfect. Yeah, so here we go, friend. The entire methodology of the rails, the only thing that must be accomplished for the principle in question is the rails must be parallel to the water. It's all that has to be done.
I agree.
And all you need is a methodology that makes the rails parallel to the water. And all that is a distance from the top of the rail to the water's surface. And that's all they have to do. All that other methodology and including calculations for Earth curvature is superfluous.
Sure, if you look at the document, they didn't actually measure it off the water surface. If you were to look at figure 4, you can see that tank isn't full. They're not measuring off it. And figure 7 shows that they're using the microscope and the string line and the rail to check the deviation.
Yeah, so I'm not sure about this particular setup, but the other setup, which we already critiqued the last time a guy came in here with tow tanks, is they have a water channel next to the rail, and they use that water channel as the leveling channel. It's not the water in the channel.
Well, I'd love to hear about that. So which tow tank was that?
They're assuming the equipotential would be equivalent in both instances. So what they're doing is, really, truly, they're just making the rail parallel with the water. That's it.
Yes.
You said so yourself. That's the ultimate goal, is that the rail is intended to keep the same drag line on the boat, continuous over its entire journey on the rail. Now, in order for that to be true, it must be what? Parallel with the water's surface. That's all they're attempting to do. No, which is assumed to be curved in your worldview.
No. Well, yeah, they assumed it to be curved. We gave them the prediction that if they set the rail at a certain curve, it would match the water, which came true. And predictive evidence is the only good evidence.
How, listen, how are they making the curve on the rail, friend?
They get the string line and they
The only way to curve the entire rail
based on their model.
What's the length of the line?
They adjust the rail, though. They adjusted the line.
Wait, no, they adjusted the rail. They didn't adjust the line. You were wrong about that. Remember, you
so what I read was wrong.
They adjusted.
So what I read was wrong. That wasn't me freestyling. I was reading.
What you read didn't say they adjusted the line. If you look at figure 7, you can see that on the rail where they have 2 pins and they have a microscope pointing at the string. Okay. So that means at any given point, they can look at their model and they can see how far should the pins be from the string at this point.
Excellent. So they didn't measure it in between the 2 points, right? Just like the laser test?
Say again?
So they didn't measure between the 2 pins, right? Just like the laser test?
They did, yeah. They measured between 2 things.
Right, but I still haven't gotten the answer to 2 questions.
In between the 2 points, because if you have a curve, then you need that the hump in the middle of the curve. So you're supposed to have
That's what the strings for.
The strings to measure the hump.
Yeah, the string is a reference. It's completely horizontal reference, right? So from 2 points, it will be.
Yeah, he also claimed.
2 points.
Yeah, before you continue, we got a caveat before you continue that the allegation is that they. Go ahead.
Excuse me, Indio. I'm trying to listen to Arden right now.
Yeah, well, no. So they presuppose
I yielded the floor, brother.
Just wait, Indio. Arden.
Yeah, great. Stop moderating our fucking chat, douche. Okay?
Yes, if you were paying attention.
They took the rail.
I yielded the floor to Indio.
I know. I don't know why you have to say it again. Stop humoring this clown, okay?
All right, my apologies.
So, listen, I'm not falling for the distractions, man. So they have this beam, right? This rail, and they can adjust the rail, and they pull the string. And so, what are they adjusting both at the same time until they're within
Why do you think they're adjusting the string?
Because they think the string has to be within a certain distance of the rail, right?
No, the string just has to be a reference, a horizontal reference.
But they don't know if the string's horizontal.
Yes, they do. If you get
how do they know that?
You pull it taut between 2 points with very little catenary effect. It is a horizontal. It is a straight line.
How do you know there's very little catenary effect? That's what I'm asking you.
Because that's what they said.
Yeah, but very little is also some. They're only seeing a small deviation, which is very little. So they're seeing the very little catenary curve. What are you talking about?
How do you know? You're assuming that because you're biased.
You just said so. You just assumed that there's very little catenary curve. Your answer was because they said so.
Yeah.
Yeah, let me ask a question.
What is
For
the value for the
clarification.
catenary curve? And then, like, how did they measure this? Because you're going to have two inverted curves, right? You have the curved rail, and then you have the curved string. And the curves are opposite to each other. So one's curving down and one's curving up.
And it's a very...
Yeah, but I also want to know how long...
It's so hard they can't even measure
Friend.
the amount of catenary curve in the string.
That's not my problem. That's your problem.
Right,
No,
but also I just want to quick qualify.
Some catenary effect doesn't mean that catenary effect is enough to screw up their model.
They have to measure it, brother. Otherwise, they wouldn't know. By the way, also, you were asked... Hold on. It doesn't matter, dude. I just said they would have to. I'm trying to get to a different point.
The entire problem is that there's a catenary effect. Isn't that your entire problem at the moment?
Listen, the catenary effect is a constant in physics, bro. It can't be negated.
Yeah, but there are all sorts of problems that anything that you physically do, like there's some form of like tiny 0.000000001 problem in every single thing you do. But if it's not enough to screw up that thing, then who cares? It's like saying
right. So, friend, for goodness sake, stop talking.
That thing can still work.
We all know that. Okay, what I want is the brass tacks. How long was the string? How was the? Shut the fuck up, kid.
Why?
Thanks.
All you're going to do is you're going to ask...
Because I'm trying to complete it, dude.
When the...
Alright, I'm just... Dude. These things matter. So stop frickin' sidelining. For goodness sakes. You were asked how they know it was horizontal. You just said they affixed it to 2 points. Being randomly affixed to 2 random points in free space doesn't prove that anything's horizontal. You then said... They got rid of the catenary. That's how they knew it was horizontal. But you didn't prove how they knew it was horizontal.
Didn't have a great
Dude, I'm speaking. Thank you. You then said that they got rid of the catenary problem somehow for whatever methodology they used, which you didn't quantify. You didn't give us the length of the string, so we can't even calculate any of these problems to even begin to say. So far, all this is a fanciful assertion with no data and no quantification to it.
Yeah, the engineers made it. It worked. They referenced they referenced the methodology they used. You just don't have the actual numbers in front of you, so therefore it's wrong. That makes no sense.
Dude, you haven't presented them. And your appeal again is just to the pragmatic at work. Dude, listen, the methodology they used got, let's just say for lack of a better term, it got the rail parallel with the water. Great.
Right.
What does that prove? Nothing. It just proves that the rail is pretty parallel to the water. That's it.
Pretty parallel?
Yes, because of the sentences that you just talked through everybody about error bars and all this other nonsense. You know it's not perfectly parallel. Good grief, dude.
So, Heretic, you said it's a pragmatic appeal again, but it isn't actually a pragmatic appeal.
It is. You said it works.
No, a pragmatic appeal would be for something unknown and unmeasurable.
What?
Where's the measurement?
Making up our own definitions.
It's for something unknown and unmeasurable, something abstract, like astrology works.
It is unknown. You already told us it was a gap in your knowledge, dude. You already told us the measurements that we needed were a gap in your knowledge, so they are unknown and you don't have the measurements. Yeah, okay, how do you know they don't know what they know?
You also admitted it was a gap in their knowledge because they didn't add it in there and have it nowhere presented, so...
Yeah, so let's link their engineering specs for this whole thing. Do you not understand that?
Right, but the other one that we did, bro.
Find a flaw that you can exploit in this when you guys don't have a single measurement of straight. Like, I gave a glaring flaw in your laser test. You
didn't. Actually, you just showed your ignorance. You actually just showed your ignorance.
Did I, Indio? Do you want to talk about that? Do you want to? If I get 2 points across a bay and I just measure what point A and point B's temperature are, does that tell me the refractive index across the bay? 1, 2, 3.
No, it does not tell you the refractive index across the bay.
It could,
because
possibility.
You
could you explain how it could?
You could apply modeling and you could assume it,
They didn't apply modeling, though.
Yeah, why would you?
So
You need
they
to
didn't
first
calculate a
establish that
value?
there is refraction. You need to establish that those models are correct.
But you can't establish if there's refraction unless you measure a difference across the bay, can you?
They
Yeah, that
didn't.
would be
They
something
had two.
different.
They did have two meteorological stations at each end.
Yes,
You
of
know
course
that,
there'd be
right?
something different, Drace, you fucking idiot.
So you
No,
do know
you're
that
the idiot
two
here,
meteorological stations, right?
Yes.
You know.
And they said meteorological station 1 and meteorological station 2 show X, but all that distance in between, they didn't measure any points on that and then map out the refractive index. Refraction doesn't happen between point A and point B. It happens the entire way in between. As any sort of change.
No, that's not how
deviation in the
refraction
atmosphere
works.
happens
That's
between
not how
point A and
refraction
point B.
works.
Of course it does.
No.
Light goes
Show
from
that.
one dense medium to another dense medium. All that has to be is a change in temperature, pressure, or like humidity of that air.
No,
Any
it's
change
not.
at all,
It's
any deviation
called
at all will
optical
cause the beam of
density.
light to
It's
move.
not just the density
Yeah,
of the
we
medium.
covered this with him before. Yeah, we've been over this
Yeah.
optical density. He
What
was
about it?
furiously Googling or something. Anyway,
Yes, you guys say it's optical density. Optical density can be changed by factors like temperature, the density.
Yeah,
It can,
the amount
but
of
you
refraction.
also require
Can't it?
you also require the correct boundary conditions to those temperature gradients to be able to refract things, and you don't
So-
have those
You don't-
conditions all the
there's no
time. And
boundary
it also
conditions.
it depends on those angles and the optical gradients.
So
which
you know what,
direction the
like,
light goes. The
ISO
light can go up and down.
So you know what, like ISIL, not only did they horizontally pan it, they vertically panned the laser, and on top of that, they did it twice. They did it twice 3 weeks apart, and they got the same result. So they just have like,
what does that mean?
so they have to have the same magical refraction conditions, the same 2-3 weeks apart.
And in different directions at different ranges. They didn't just horizontally pan the laser. They panned the laser horizontally.
It seems like they had different outcomes.
See, here you
for
go
each-
again.
I'm
Stop
speaking,
talking.
brother. Okay?
AI, please.
Yes. They panned the laser to targets at different ranges. So, for example, in the 25-mile shot, the 25 miles was the final target, but they panned it through like a 4-mile target, a 14-mile target, etc.
And this was done 3
Yeah,
weeks
it seems
apart.
like they've got different. It
The
seems like
firing
they've got
line is hot.
It
It seems like they have different what?
they have different measurements for every single laser test that they did.
What does that mean?
Well, considering
Different
that
measurements of
they say-
what?
They say refraction exists. Yeah. And they say that the laser is hitting different points, but it's just within the tolerance that they set based on the refraction that they think, to fit a flat Earth model, right?
No, they're
So it
tested.
seems
They
like-
tested the WGS 84, and it's outside those values by 2 orders of magnitude.
Because they didn't look at the refractive index between the 2 points. So
Oh,
the 2-week change would cause a small change in refraction in the refractive index, right? It wouldn't be
okay. So how
massive.
much refraction does there have to be to get the result they got?
Well, we could look at that if you'd like.
Yeah, let's look at that. Give us the model that can make that prediction.
Let me know when you're done with
Walter Bislin Advanced Earth Curve Calculator.
That doesn't. First of all, there's no predictions in that. I said a model that makes predictions, not post-diction.
Yeah, so the Walter Bislin Advanced Earth.
Yeah,
Earth Curve
those are
Calculator. If you
post-dictions. I want
put relevant
predictions.
Observation data, and then you just change the refractive index.
Yeah, that's a post-diction. That's not a prediction.
I just
Yeah, hold on.
for a second. Let me know when you're done with this point so I can jump in because I wanted to ask him a question, but I'll unmute him.
Yeah, but I want to.
I
wanna-
since
no,
you
don't
have a
unmute
limited
him.
amount of time, Miggy. I'll just yield for you.
Yeah, I will let AI because I don't know. You guys were in the point right now, but I don't know. AI.
Yeah, we can wrap it up very quick. So what he did there is he has an ex post hoc solution because he's going to go to this calculator and just change the dial until the dial fits the observation, which he already said he will do, which is no observation can debunk the globe because you can always input refraction to be sufficient ex post hoc. which is not proper reasoning or proper anything. All right,
And, and basically, the calculator doesn't simulate anything. If you look at the Black Swan so-called simulation, okay, if you look at the rays, they invert. So the image that you should be shown should be half inverted. But he doesn't show that, right? So all he's doing is adjusting pixels up or down, but never adjust the orientation. So that calculator doesn't simulate anything.
Well, it does simulate one thing, so let me finish up with this, is that it simulates an increase in the radius of the Earth to lower the Sagittar via the circle segment formula. In other words, it models a lower hump between point A and point B, which means it's effectively flattening out the Earth to account for observations that debunk the globe, conceding that the Earth looks flat. I yield.
Okay. I'm going to unmute him. Dogs, if you can hear me, I just need to ask you a question before you go on. Or maybe you just want to respond real quick so I can ask you?
Yeah, it'll only take me 2 seconds to respond.
Yeah, go ahead.
The problem is what you said about Walter Bislin's Earth curve calculator flattening out the Earth is that it flattens out the apparent geometric horizon, not the actual one. You get that? And there's no problem with a post hoc falsification of an experiment. The problem is if you have a positive claim and you want evidence for that positive claim, you then need to make it predictive. So I'm not saying the Earth is a curve because I can post hoc use refraction to account for a flat Earth like experiment.
Man, I want to respond, but go ahead, Miggy. I'll bite my tongue till later.
Yeah, we'll just, I guess you can respond. I just wanted to ask you maybe 2 questions. Can we know 100% sure that the Earth is a globe in any way?
No.
Okay, second question. Has anyone directly measured surface curvature?
Yes.
Okay, can you tell me who?
Transcontinental arc, the parallel.
Who? No, that's not what I'm asking. I'm saying who directly measured it? Was there, what persons were there, or people? Was there a group of people?
I could find the people that did it, but
no, I know that, but I'm saying, do you know?
That's called a genetic fallacy, so it doesn't really matter.
No, I'm asking you a question though. Either you know or you don't, right?
Not off the top of my head, no.
Okay, so you don't know. Yes, it's a problem. It's definitely a problem because the whole topic and the debate surrounds the information of a baseline of knowledge that you do not have, which right now currently seems to be stemming
from. How does the knowledge of who made the?
Okay, so I'm trying to tell you, unless you want to interrupt me and then form your own conclusion. It's up to you. So the knowledge base of what you have right now.
You lagged there, so I interrupted while you were lagging.
Oh, all right. So, can you hear me now? Hello? Can you guys hear me?
Yes.
Okay.
Yep.
So basically,
go ahead.
Okay, so the knowledge base that you have right now is built on derivative topics that's surrounding like a giant puzzle piece that you're trying to put together. They're like all these little clues are going to equal to like curvature. That's what I've been listening to for the past, I don't know, hour and a half that you've been in here. And it's what it sounds like to me. You have a lot of evidences that are going to equal to your answer. Is that correct?
That is correct. What's wrong with that?
Because it's not one single direct measurement of the thing in question. So let's put it this way. I'm just going to give you an analogy, right? Like the ones you've been using. So basically, if I have a basketball and I tell you it's a cube, you would be telling me that it's incorrect. And I would be saying, how? You said, because we can directly measure this thing, which it turns out it's going to be a sphere with a radius, diameter, and circumference. And you can show me how in math, also in principle, how this actually operates in reality. So if I was to tell you to do the same with the geometric shape that you're actually standing on, it would not be the same. And I would ask you why? Because it's the same thing in reality, something tangible, something you can actually look at, and you can actually apply maths and then directly measure the thing that you're in question, right? So in this instance, it feels like it's a bit more obscure, and all these little clues that you're talking about don't seem to add to the single direct understanding that we know that the Earth is curving with the set rate that they're telling us with the diameter and radius. So what we're doing right now is we're going round and round and arguing about derivative topics, never getting to the underlying premise that the Earth is indeed measured curvature, because we have all the metrics, as you may or may not know. They're made public to everybody, so we can pull those up and we know what they are. So what I'm saying is that it's a fruitless endeavor that you're on right now, this quest to actually try to prove the thing that you're actually trying to prove, but without proving it directly, but indirectly. And so maybe to you that makes sense, but to everybody here, knowledge works. I know, but I'm saying, but to everybody here, it makes more sense to directly measure the thing in question, and that hasn't been done.
Can you directly measure something that is as large as the Earth?
Yes, absolutely. How? With the variable. Listen, because I'm going to tell you.
Can you do it the same as a basketball in your hand?
Yes, absolutely.
No, you can't. You can't, because you're big, and you can have bigger things to use as measuring tools for that Earth, right? For that basketball, sorry. But for the Earth, you can only measure a small patch of the Earth at a time.
So that's the thing, though. How did we do it in the first place? Because we have these metrics.
Transcontinental arc, the parallel.
Okay, so is that how we derive the metrics of the Earth? Yes or no?
Well, no. What we did is we have tested it many different ways. Some haven't been exclusive to a globe Earth. Some could be experienced on a flat Earth. But we have then done some that are conclusively for a globe Earth over a flat. Did you hear what I just said, or did you start talking after you'd rambled for like 4 minutes?
We have the metrics. You don't want to look at the metrics.
Do you hear what I just said? Do you hear what I just said, buddy?
No, because it's not the actual direct measurement of the Earth's curvature by which we have.
Did you have a direct measurement of flat Earth? Yes or no?
I don't need to directly measure something.
Exactly. You're a fucking hypocrite.
Okay, so now you're resulting to insults because you're losing. You don't know how to provide evidence for the direct measurement of the Earth's curvature, so you want to spiral.
Transcontinental arc of the parallel. What's wrong with that?
Is this your out? Because it's not directly measuring the surface curvature. That's why. And I asked you, is it? You said no. You conceded. That's great.
No, it is. Transcontinental arc, the parallel, directly measures the curvature of the Earth.
No, it doesn't.
It does.
Does it do we derive the metrics of the Earth's size from that?
Yes.
Show me where.
Great. I will link you the document.
It's a document that you didn't read.
Yeah, the one I did read that you didn't understand. You thought that
dude, you can listen.
That they listed as direct measurements. You thought they'd already applied some form of transformation.
They did.
Read page 47 this time.
They did.
They did in Indio. Remember, you linked it to me and you read it, and it said that they had put the data in and then they put the calculation.
Sorry,
it's called a horizontal reduction.
So,
right?
like, listen, I asked him for direct measurement. He said no. Now he's saying yes. He's going back and contradicting himself. But what he's going to post, because we've all seen this document, right? This PDF. I think is it page 19? Is it on the 4th paragraph? He's going to be astounded to know that it's not. They didn't directly measure anything. They actually pulled it out the Clark spheroid model. That's what they're using. So they didn't measure the curvature of the Earth.
He's denying that that's what they did.
Right, but that's what it directly says on the PDF that he's probably going to post if he hasn't posted it already.
He's denying it means that.
This dude is infamous, though.
In his own meaning.
He's infamous for denying his own references. That's all he does here.
So the thing that I asked him were 2 questions. Can we know if the Earth is measured to have curvature? He's for 100%. Like, can we know that? He said no. Second one was that has it ever been directly measured? And the answer was still no. It was because he's trying to use all these derivative topics to ruffle feathers and try to make it seem like he has a point when he does not. And he starts to get angry and starts to put out insults because he doesn't have an answer. But that's all I wanted to say, just to expose him that he doesn't have an answer. And he wants to dance around and that's all he knows. And that's all I have to say. I yield the floor.
I did notice he had a lot of direct, pointed personal insults. Now, I did swear at him to say shut up because he was constantly over-talking and through-talking.
Okay, can I talk about Mickey for a second? And how he started off with a genetic fallacy?
We'll talk about him, or do you want to talk about the arguments?
No, his argument. His argument was a genetic fallacy. His argument was, I didn't know who did the measurement, so therefore the measurement is wrong.
That's not a genetic fallacy.
No, he was talking about you. He wasn't talking about the argument.
I don't know who measured the transcontinental.
No, he's pointing out that you have a belief. That's what he's pointing out.
Yeah, you just have a belief.
That's exactly how he started his argument. Is that how you started your argument? Because I wrote it down.
Yeah, that's
number
okay.
one,
If you
is
think about his
100% sure
first
the Earth is a
question,
globe. I said no because we can't be sure of anything. It's basic epistemology. If you knew anything about knowledge, you'd know that.
Oh my
Number
goodness,
two,
dude.
You said that because I don't know who did it, I'm lacking some knowledge that makes that an actual like a good argument. When that's just
no,
not true.
that was your interpretation, but he never said any of those
No,
words.
he specifically said I was lacking some fundamental.
Yeah, that's right, but he didn't.
About my own sources that would make my sources incorrect.
No, you're adding that yourself. The incorrect part, you're adding that. He never said that part.
Okay, so for everything
You're
I've argued so
adding
far, what have I done that have made my arguments incorrect?
Okay. He wasn't arguing against your arguments. He was illustrating the fact that you have a belief.
He was using a genetic fallacy, yeah.
No, dude, what don't you understand? He was just illustrating the fact that your claims about whatever measurements exist out there, the results of which that you don't actually know are just a belief. Oh my god, dude.
Anyway,
it's about you, dude. This isn't about the measurements. It's about you. Are you like some weird narcissist?
Page 19 of the Arc of the Parallel. Isn't that great?
Dude, listen, before you read that, you need to specifically rebut the claim that they pulled that stuff off of that model.
Well, how about this? I can get right to the heart of this. Why do they use a reference ellipsoid? Why do they use a reference ellipsoid in the first place? Why is this even used? They're just measuring curvature.
We have previous information that tells us the Earth is a sphere. So based on that previous information, people now assume it because it makes sense to do so.
But why is it used in anywhere in any calculation ever? Why do they need it? Why does it necessary?
We have previous evidence that the Earth is a globe.
Okay, that's awesome. But why do they need it? You're not answering the question. Why do they need it in the equations? Why does it exist?
For the
why not just use the raw measurements, right, and then just come up with it like that? Why use the measurements and reduce them to an ellipsoid? Why are they doing that?
They have the raw measurements and they have the ellipsoid measurements.
Okay, so why are they reducing their raw measurements to the ellipsoid surface, the sea level? Why are they doing that?
Because they want to fit the measurements that they've made onto one larger, grander set of maps or measurements.
Okay, that are based upon old measurements. Were they reduced to another ellipsoid?
No idea what you're talking about.
So you just said the ellipsoid is based upon measurement. Dude, don't overtalk me. Don't overtalk me because you know you're fucked now. You're fucked and you know it, dude. Yep, that's right. You're fucked and you know it. You're fucked and you know it, dude. Sorry. You know you're fucked. That's why you're trying to fucking rabble-rouse right now. Listen, you said the ellipsoid's based upon some previous measurements. So these new measurements, arc of the triangulation, they reduce the measurements to the horizontal directions to the surface of this Clark ellipsoid. Where'd they get the Clark ellipsoid from? And when they took those measurements, did they reduce it to some other ellipsoid? How far back does it go?
Assumption upon assumption upon assumption.
To the first measurement of the radius of the Earth, you fucking moron.
When was that?
Do you
When was
understand
that?
how stupid you are?
When was that?
I don't know. Maybe I don't.
Oh, you don't know. That's
probably prior to Eratosthenes, but Eratosthenes did the first one, and then we worked out
sorry, I missed that. I missed
was actually
that.
correct using different styles
is he
of
talk about
measurement.
Al-Biruni?
We've done it
Yeah, I
dozens
missed
of
that.
different ways. How do you guys not understand?
When was this measurement, dude?
Okay, the radius of the Earth's never been measured and can't even be measured in your paradigm.
His whole argument is based on he doesn't know. That's it. I've been saying I don't know this whole time, dogs.
You blow your father with
That's
that?
embarrassing, bro.
Look, you know what the answer is.
Look. Should we just
It's
read this?
embarrassing. It's embarrassing. You're embarrassing yourself, dogs.
Yeah, you're so emotional, man. What you talking about? AI's emotion?
Go back and learn some more.
Let's have a good cry.
Yeah, I got a shoulder you can cry on. Go on. Go back to McToon and go get some more information from him because you're not up to date, bro. This is weak sauce, bro.
You guys haven't given a single argument for flat Earth.
Bro. You don't know about
Eratosthenes.
I don't know. Are you 100% sure? No, we can never be. Well, you don't know anything, bro.
Dude, it's not.
Anyone that knows about epistemology knows you can't be 100% sure about anything except.
Well, then you don't know the Earth. Thank you for admitting that.
Yeah,
And
that's nonsense.
fallibilism. It's provisional knowledge. It's knowledge that isn't 100% complete, but it's still knowledge. You have two competing hypotheses, and one has over 50% probability of being correct based on predictive evidence, then you should go with the hypothesis that has a greater predictive evidence. This is epistemology 101. It's fallibilism.
Dude, you just don't know. That's
your lack of fundamental knowledge about knowledge is the problem. That's why you're all fucking flat earthers, because you're too dumb to understand.
You don't know anything, dude. I love it. I love that you don't know. Please.
What he basically said is that
tell me why fallibilism is incorrect.
If something has a greater than 50% probability and you have no other alternatives, you should accept it as true until something new comes along. Then it becomes false. Hooray.
Great. That's great. So give me something new that comes along that disproves the globe.
You don't know. That's all.
Nothing's come along that proves the globe.
That's all, folks.
I just gave you like 4 different things, didn't I?
Yeah, 4 different things that don't prove.
Yeah, 4 different things that you don't understand.
From towers is one. Yeah.
No, it isn't. No, it isn't, dude. Towers. Bridge towers are not evidence of curvature. You're a clown, dude.
Go try to.
We need to find some way to disprove these things instead of just saying.
You haven't proved it in the first instance, you weirdo.
I didn't add in this specific number.
You haven't proved it in the first instance, dogs. So don't even be saying that you got all this evidence. You got shit, bro. You ain't proved nothing.
Can you tell me what's
over here saying that? I don't know. I don't know. That's what you said, bro.
We got to do that again.
Jesus. If you read that document, there's not enough information in that document to make an evaluation. And
but
you
that
claim
doesn't mean it's wrong, does it? The experts, the people that built it, say
the experts. Exactly. Exactly. You just said it all. Your actual true epistemology. The experts.
Oh, by the way,
you talk all highfalutin.
By the way, that's a genetic fallacy. The experts. It comes from the experts, therefore it's true. It's a genetic fallacy.
A genetic fallacy would be because they are the people that did it, it must be correct. But the problem is that they did it correctly using the methodology that they chose.
Are you keep saying I don't know, dogs? We're used to you saying that already in here, so just keep saying I don't know. That'll win an argument anytime.
What's the correct methodology? How do you know the methodology is correct? Give us the methodology then.
I don't have to. The toe tank works.
Okay, so you don't know the methodology, but you know it's the correct methodology. How does that work?
The same fallacy. This is crazy.
It works, dude.
The tank works.
And because the experts worked on it, and it works.
Because the rail and the...
So nothing to do with their methodology, just the experts, exactly like these guys just said. Cool.
No, the thing itself, the toe tank works. That's evidence that the engineering works.
Yes.
Works because the thing works. That's how engineers work, you idiots. Do you not understand this?
Yeah. So I got a PDF from an engineer from Australia that says just because it... Oh, do you want me to... Okay. Now, hold on.
I read your last PDF. Do you remember what happened there?
No, I don't. Well, you read what PDF?
Big failure in them not calculating refraction across a body of water?
Yeah, they don't. They don't need to because it's an unproven quantity. Gee, that's why I asked you. Let's actually go back to that.
Wait, is this a YouTube video?
Let's go back to that.
Video? This is the calculus they won't teach.
Listen, don't mute him anymore. Let him talk. Right? Don't interrupt me. We're going to have a real interchange. Fucking interrupt me, I'm just going to kick you the fuck out of here. Okay? It's going to be like that. So check this out. I asked you, what model for refraction should we use to make predictions? You are aware that there are probably a dozen to maybe 24 models of refraction going back 150 years. Which model should we use that makes predictions?
Snell's law.
Which one?
Snell's law.
Snell's law doesn't work.
Why?
Because it doesn't preserve the angles.
It doesn't preserve the angles. That's the whole point of refraction. Refraction is the angles changing.
Okay, so in a gradient index medium, you can't use Snell's law because the angles are not preserved. Okay, so hold on, I'm
The
describing
angles are not preserved. Can you explain what that means? Because the angles aren't meant to be preserved. The angle is meant to go from A medium to B medium. The angle is to change, the inference angle.
Yes,
and then
that's
from
right.
B medium to C medium is meant to change again. Then from C to D, it's meant to change again. Then from D to E, it's meant to change again. So at what point
Sine
should the
theta is
angle
a conserved quantity in Snell's law.
Say again?
Right.
I didn't hear
Sine
that. Say
theta.
again?
Sine theta, the angle is a conserved quantity. Okay, so the angle of incidence and the angle of refraction have to sum to 180 degrees, right? Because they
That
have to
makes
be
no
normal.
Sine theta has to be 180 degrees.
The sum of the angles, the sum of the angle of incidence to the medium's interface, right?
Yeah.
And the angle of refraction have to sum to 180 degrees.
Okay, and?
Okay, so in a gradient index medium, that's not the case. If you apply Fermat's principle, I just posted a PDF that runs through the mathematics. I don't expect you to go through it now.
Live stream text?
Is yes, right? I even posted the PDF, right? So it says sine theta conserved along the light path. And it goes on. Snell's law states that the quantity sine theta is not changed in the refraction of light passing from one medium to the other. We acquire whether this is true in a general case where the speed of light varies continuously within a medium. That is a gradient index medium, right? So you have to apply Fermat's principle, right? The principle of least time. So you understand that. Final result of these exercises is that, contrary to initial expectations, the answer to the question in the title is negative. So there's problems with using Snell's law and a freaking on like some gradient index medium, because you would end up having weird ducting, weird reflections, right? So if you modeled, right, so a medium with n number of indexes of refraction mediums, how many freaking layers are you going to use? Right. So what you could end up happening is the light being trapped within one of these layers and never exiting, especially if the light ever ends up going horizontal. So if it ever ends up going horizontal, it's never going to transition some barrier, right? Some interface. So if you look at Andrew Thomas Young's website, he admits this, that results in a singularity if you use Snell's law, right? If you use Snell's law and the Earth is flat, right, and you have a medium at that level, so 6 feet, right, and you even have a gradient, right, you can even have a temperature gradient, that light, if it's horizontal, will never transition into any other refractive index medium, because it's horizontal over a flat plane. So if you model it out mathematically, yeah, it'll just go on forever, right? The only reason you all say there's bending light, right, is because you have a curving gradient. I'm not gish galloping. Just because you can't comprehend what's being said, because this is above your pay grade, ain't my problem. That's your problem.
Well, I'm reading through this and I'm not seeing the part where they conclude. So what page is it where they conclude?
The conclusion? Scroll down.
Yeah.
The conclusion's literally in the abstract. You don't even have to read the conclusion. You can scroll down to it.
So in the introduction.
So you see, you've never read actually any scientific material, so this is just like fucking Chinese to you.
Well, the conclusion is usually.
Oh, I've been reading this shit for 20 years.
It's in the abstract.
The conclusion is in the abstract. The answer to the question in the title is negative. Is sine theta conserved along the light path? That means, says, Snell's law states that the quantity and sine theta is unchanged in the refraction of light. Is sine theta conserved along the light path? The answer to the title is negative. The answer is in the abstract. They don't use Snell's law to model in physics, gradient index medium. Abstract, I posted it literally in the chat.
It also provides.
Look. The
final results of the exercise is that, contrary to an initial expectation.
Let me ask you this: does Walter Bisgund's simulator use Snell's law?
Yeah.
No, it doesn't. It uses Fermat's principle.
Okay, if he uses Fermat's principle, who cares?
Okay, so does Mick West.
What's the difference? What's the applicable difference between the two?
Is that there's no boundary.
In Fermat's principle?
Yeah, there's no boundary. You integrate over the light path, basically.
No. Yeah.
It's to use the calculus of variations of integrate over the light path. Whereas one is just simply algebraic or trigonometric, if you want.
And?
That they're not mathematically equivalent, dude.
They are
You understand?
mathematically equivalent. The outcomes are still generally the same.
No, Snell's law is a special case of Fermat's principle.
They're still...
Where you have a well-defined medium. No, they're not.
Yes.
Snell's law is a special case, right? Snell's law is a special case where you have two well-defined mediums with a well-defined boundary.
Based on Snell's law and Fermat's principle, would they be roughly equivalent?
In one case, where you have two homogeneous, a medium where you have two mediums with different refractive index that are homogeneous, isotropic, and have a well-defined boundary. That special case, that's what it models. Which is great for designing lenses. Right? You can use the thin lens equation, no problem. Easy peasy. Then you still get to the engineering.
That's principle, which states the light travels the path which takes the least time. By taking the derivative of the optical path length, the stationary point is found, giving the path taken by the light. And there are situations of light violating Fermat's principle by not taking the least time path, as in reflection or a spherical mirror. In a classic analogy, the area of lower refractive index is replaced by a beach, the area of higher refractive index by the sea. And the fastest way for a rescuer on the beach to get to the drowning person in the sea is to run along the path that follows Snell's law.
Yeah, because you have a well-defined boundary. Sand in the water. You go one speed over the sand and another speed over the water. So you want to find the path which is the most efficient to reach the person. Well, the principle of least time. Which one takes you the least time? Should you run through the sand more? Should you freaking swim more? Which one should you do?
Great. So they both use the principle of least time.
Fermat's principle, or Snell's law, is a special case of Fermat's principle.
Right? Okay, great. So why doesn't Snell's law work?
I told you, because it's a gradient. So now you have the sand, right? So the sand is continuously varying. In the water, your speed through the water is also continuously varying. Actually, there is no sand in no water because there's no well-defined boundary. It's just all sand. And your velocity through any given point in the sand, like at point, there's 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, but there's a continuum. It's a continuous change. It's a continuous change, right? It's not a discrete change, like at a boundary, which is Snell's law.
Why is that a problem? So think about it like this time. You have X speed on sand, X and Y speed on water, and then you replace that water, and you have the speed across just sand being equivalent to the average speed between X and Y. And all it is just...
I don't know how to explain this to you. If you don't understand basic mathematics, I just don't know how to explain it to you.
Well, I just explained to you what Snell and Fermat's law, the difference in the principles. One says you go from X to Y, and the other one says there is a gradual change between X and Y. But if they both end up with very, very similar end results based on, the different optical...
Do they end up with similar results?
Of the mediums? Yeah.
Yeah, where's your evidence for that, dude? Like, seriously.
The paper you cited. They only found very, very small deviations using different calculations. In your paper that you cited.
Well,
every FLIRF paper disagrees with them.
What did you say?
Every FLIRF citation disagrees with them.
Dude, okay, you just said that there's a difference. Previously, you said they were the same. Okay, it doesn't disagree with me. It disagrees with you. That's a crazy projection. Now it's close enough. Before you were saying it was the same.
I'm waiting for evidence that it isn't. Can you tell me why Snell's law wouldn't work across a lake?
Because it's not a well-defined boundary, and it's a single medium, so they have to
You can take all the different mediums, and it's not a single medium because optical density changes depending on the temperature and the amount of air, the amount of water in the air, and the density of the air and the pressure in the air. So you can.
So tell me, how, in reality, how would you model this out? How would you model this out? This gradient, right? This air gradient. How would you model this out?
I don't know. I don't have enough knowledge in maths for that, but I understand the concept.
Yeah, yeah. So you would have to use an infinite, like an infinite amount of
to B density, or X density to Y density.
How many layers do you need?
Is that there is a gradual change between A density and B density. That's all it is.
How many layers until you approximate Fermat's law?
I don't know. I don't care. But that doesn't matter.
I know you don't care.
And this is amazing. This is amazing. You're doing a reification.
Yeah,
fallacy.
now you're going to talk about me again. How predictable.
You're doing a reification fallacy.
No one is reifying it.
You know
I'm asking you. You say refraction exists. I'm looking for the evidence that it exists. I'm looking for the model that makes
a mathematical
so that we can.
Is it something that exists in reality?
Yeah, refraction as a general phenomenon exists. Refraction bending light around the curve of the Earth. Does that exist? That's what we want to determine. Does that exist? What is the evidence for it?
What is the boundary in Snell's law? Does that reference something actual, like an actual boundary, or does it reference a mathematical?
Yes, it's an actual fucking boundary. Yes.
No,
it's where one medium becomes another medium. The atoms on one side is.
I've ever heard. It doesn't.
Oh, so water. No, Elijah, please don't. Please, I'm asking you, please. I want to finish this. He's going to try and get off it. I'm not letting him get off of it.
Why would you think calculates the optical density of A and the optical density of B, and then it arbitrarily pops in a boundary between them?
Where do you think they would pop in that boundary?
What?
At the end of A, at the spatial end of A, and at the spatial beginning of B? Do you think that's where the boundary is? So if you have two substances, one's water and one's glass, the water's not the glass, and the glass is not the water, and where they meet is what we call the boundary.
They can both be water with two different optical densities.
So water can be water, and glass can be water and glass at the same time?
No. Indio, listen to me, okay? You can have air, just air, but if the optical density of air is different at 2 points, in Snell's law, you'll take those 2 points of measured optical density, so the different temperature and pressure, and you will put a boundary in the middle of that calculation. And that boundary calculates the deviation, the refraction.
That's why I asked you how many layers.
Going from A to B. Whereas in Fermat's, it will be a gradual change. It won't be a defined boundary they put into the calculation. It will be between A and B, there is this amount of change, not it changes at a defined boundary, okay? It's all abstract, it's all mathematical, and it's called a reification fallacy when you say that there's an actual boundary in spatial reality.
No, what I said was there is a continuous change in Fermat's principle, and you just made my argument. Thanks you very much. Snell's law. Snell's law has a boundary. Snell's law has a boundary.
I've ever.
Dude. Snell's law. Oh my God, the fucking spiral. Snell's law has a boundary. You said that you can make an arbitrary boundary. Where do we make that boundary? How many boundaries? That's why I asked you how many layers. You didn't even understand what that was talking about. Like, how would you model this? How many layers do you have to do? If I take six feet of freaking air, right? How many layers of Snell's law of different refraction index to model this gradient do I use? Do I use 10,000? Do I use 1,000,000? Do I use 1,000,000,000,000? Do I use an infinite amount? Right? When we use an infinite amount, well, oh my God, that's fucking calculus. And we use a continuum. And look, the continuum's more accurate than the so-called simulation of boundaries. I don't know why you don't understand this. Oh, because you don't know anything about mathematics. But your whole idea of refraction is based upon mathematical models, which don't work in reality, which make no predictions in reality. That's why I'm going to ask you again. I know someone muted you. Give me the model of refraction that makes accurate predictions that we can test, so that we know which one to use, so that when we make our post hoc claim, we can be using a model which has some predictive power. You even said We need predictive power to tell us what's likely true. Give us the model with predictive power.
Both.
Give me the exact model with predictive power.
Both.
Okay, so those are models. How were they tested?
I can find some journal articles if you'd like me to.
Yeah, I'm sure I've read them all.
Awesome. But are you willing to admit that the boundary is just what they put in? Like it's the maths that they add in to say that there is a defined...
They don't use Snell's law for a gradient, you clown.
A defined point between the refractive index of A and the refractive index of B, right? So all they've done is they've said there has to be a boundary here instead of it being a gradual change.
Okay.
Are you saying that is bullshit?
No, when they model it, listen, when they model it in reality, right? Like if they model it between glass and water, they'll use Snell's law. But if they have a gradient, they're not going to use Snell's law. So when I say the Snell's law is an actual boundary, that's what they're modeling. They're modeling an actual boundary. They're not going to use it in a situation you're talking about. They're not going to use it for a gradient index medium. They're just not going to use it. So it's
like, why not use it? If it's easier, because Snell's law is
because it's inaccurate.
Principle, isn't it?
Because it's inaccurate.
To what percentage? To what percentage?
It probably depends on the application.
Oh, okay. So we can use Snell's law if we want, say, a couple of percentage points of accuracy. And then Fermat's if we want, say, a couple more points of accuracy. It's the same with Newton's and Einstein's, isn't it?
Well, it depends on the distance, right? So it depends on how long the light is within the medium, right? So that's the defining factor. How long the light is inside the gradient versus, or how many layers you model. So there's all different, depends on your model, right? So that you could probably make a situational Snell's law model and use Fermat's principle and get them fairly correct, probably for good enough for practical purposes and make it quote unquote work, right? But it's not what's used in the common practice. They just use Fermat's principle because it's more accurate. That's just what they do.
So they both would work. One's just more accurate.
But the fact of the matter is, you can use Snell's law. You can use whatever the fuck you want.
You thought that this boundary was a physical boundary, you fucking goose.
No, listen, in the use that they model it, it is. Yeah, in the use that they model it, it is. Whether you actually use Snell's law to model something,
it's real. When they model it, it's an actual boundary.
No, listen, they don't model gradients using Snell's law. Only dumbass fucking anti-flat earthers use it for that. That's what I'm trying to tell you. Only you fuck clowns use it for that. Nobody uses this. If you go read all the literature, no one uses Snell's law for this shit. Nobody. Not a fucking person. Only Dunning-Kruger anti-flat earthers use this shit.
Does it still work? Does it still work?
No!
Why? What's the percentage difference? How many decimal points are different?
I just told you. I already answered that question. Depends on the application.
You don't know verification policy and you don't know, and you're trying to lecture me about the maths. At least I was big enough.
No, listen. I told you the situation. It depends. It depends on the situation. It depends on what you're modeling. The error depends on what you're modeling. If you're modeling how long light's in fucking 1 millimeter of a gradient, dude, yeah, they're going to be almost identical. But if you're modeling how far, like if it's going through fucking 1 trillion miles of air, that's something else. You're going to it depends. It depends on the application.
I think we're done with this now.
No, you're going to give me the predictive model. Dude. You're just going to give it to me because we want to know when we do our post hoc, ad hoc bullshit at the end, right? So we can't falsify the globe. I want to know what model we have to apply.
You're obviously too
I want to know what model, dude. I want the evidence. No, I want the evidence for your foregone conclusion. I just want the evidence. That's all I'm asking for. What's the evidence, dude? What's the evidence? What's the evidence any of these models work? What's the evidence that that light is bending around the curve? What model predicts that? And then that model has been validated by observation.
Great. I'm looking up
really simple.
Theoretical and experimental study of refractive indices of water, acids, and nitrile and salt systems.
Yeah, so I'm talking about terrestrial refraction.
They calculated the refraction.
I'm talking about terrestrial refraction. This thing that's supposed to be like bending around the curve, making everything look flat.
If you apply it to the surface of the Earth. No, these are physical constants, buddy. Do you know what a physical constant is?
Dude. Okay.
Dude.
That's a cool story. physical
Cool story,
constants,
bro.
yada, yada, yada. Cool story, bro. I'm asking for the model that makes predictions that we can apply in real
I
life.
propose a simple theoretical formula for describing the refractive indices in binary liquid mixtures containing salt ions. Our theory is based on
Okay,
the Clausius-Massotti equation. It gives the refraction index of the mixture in terms of the refractive indices of the pure liquid and the polarizability of the ionic species by properly accounting for the volume change upon mixing. The theoretical predictions are tested by extensive experimental measurements of the refractive indices of water, acetonitrile salt systems for several liquid compositions, different salt species, and a range of salt concentrations. Excellent agreement is obtained in all cases, especially in low salt concentrations with no.
Are you almost done, like doing nothing?
Expression of the refractive index for low salt concentration is also given, which can be a theoretical basis for determination of salt concentration using refractive index measurements. So it seems like they've come up with a very, very simple equation for refraction based on this one specific liquid, and it's been correct. They tested it, and it was correct.
Yeah, awesome.
Okay.
Yeah.
So now we're going to apply that to the air. What model is used for the air?
Just a second.
It doesn't matter. There's not a big deviation.
It doesn't matter.
What I love is they're using a tank and a solution and allowing it to set so it becomes homogeneous and isotropic.
Are they?
Yeah.
Are they? Because what I just read out.
Because when you stir the solution, I've seen many demonstrations of this.
Okay.
When you stir the solution, you see no deviation.
Look, I'm just looking for the justification for claiming that there's terrestrial refraction fucking up all our measurements with a laser. I want the justification for that. And you can't seem to come up with one. Other than because I said so.
Experimental determination of the refractive index of Snell's law. This experiment uses a narrow beam of light passing from air into glass and then into air. The experiment is practically easier using a hemi-cylindrical prism of glass with a beam entering the curve.
These are inapplicable to what we're talking about.
Why?
You're just Googling random shit on refraction, dude. Terrestrial refraction. Google that, brother.
There's
dude, you think I don't know you can look for this?
An experiment showing refraction works, but you don't like it because you don't seem to understand that Snell's law, being a model, means that there has to exist things in real life.
You can claim it works in different applications that have nothing to do with. We want to see it works in this application.
In what application? Through air?
The application of a laser or a ray of light through air, dude.
Great. Refraction over water experiment. Have you never typed these things in?
Look, dude.
No, you haven't, have you?
What are you talking about?
It's much easier to just sit here and go around in circles about things that you don't understand rather than just go,
yeah, talking about me again. The old standby.
Hey, so anyway.
No, we're going to finish this point. I don't care how long it fucking takes, dude. I don't. So, we're going to finish this. I want the predictive model for refraction so we know that there's a justification for saying that it exists. We need a justification. We can't just say, hey, willy-nilly, we're just going to throw in this phenomenon that we say exists. We need a justification for saying it exists, right? And one justification would be a model that's been tested and makes predictions. But that model doesn't exist, and you know it doesn't exist. That's why you're bringing up all this ancillary bullshit. And you know what? By bringing up ancillary bullshit and
predicting atmospheric refraction with weather modeling and machine learning.
Yeah. Okay. I've read that.
Would you like to read this?
I've already read it.
Have you?
Yes, I have. I read it about 2 years ago.
Oh, okay. What do they do in it?
I think they're looking at the side of a mountain, if I remember right. It's in Arizona. It's like in the desert.
White Sands, New Mexico?
Yeah, I got a pretty good memory. Seeing I only freaking skimmed it freaking goddamn 2 years ago, 3 years ago maybe. Yeah, but even if listen, so check this out. I'm pretty sure the AI successfully made predictions, but AIs are black boxes, so we don't know how they actually make predictions.
So you've read something that confirms that
no, it doesn't confirm anything. They just
weather model data results were computed for 10-minute intervals and ray tracing procedure was applied. The data is interpolated in time to align with the time-lapse image frames. Shows results of the experiment as a function of time of day, blah, 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 blah. Where is it? Measurements are only available for daytime. General downward drift through daytime hours is an effect we commonly observe in clear weather, and this corresponds to a reduction in the average refractive index gradient of the atmosphere along our line of sight.
Yeah, claiming something and showing the actual mathematics to support it are two different things.
Well, they've got the mathematics in this.
Not for that specifically. That specific claim you just made, they do not have.
I'm looking at it right now.
So what model do they use?
They have a machine learning model.
Well, you said it just matches the gradient of listen, you just said it matches the gradient of the refractive index. What is it matching? What is the machine learning matching? What model is that?
So the machine learning takes the image and then the ray tracing, whatever it is, and adds that into the known distances, and then takes all of the weather data and then calculates a refractive index based off that.
Okay, so what model is it comparing it against?
I mean, I can just link the paper. It's got all the maths for it here.
What model does it compare it against? So what you have is you have a model, and the machine learning looks at the images, right? And then the machine learning goes, if this model existed, how would this image match that model? And now I'm going to make predictions. When I take an image, how does this image fit this model?
It doesn't matter. It works.
What's the model, dude?
Refraction exists, and it's between Fermat's, Snell's, and this model, they would have similar outcomes, right?
No.
And the deviation doesn't matter because the deviation can be changed by any of the variables changing. So the refractive index should actually just be like a range, okay? So if you have like the black swan image and then you apply refraction to that, you don't just add a set refractive index. You can make that a range of refractive indexes based off the measurements you have and the variables that could change. That's how science and data works. And then from that, you can see whether that image can fit the predictions based off refraction, which would be the range of refraction.
What predictions? That's what I'm asking you. How do we make the predictions? What model do we use to make the predictions?
It doesn't matter. For math, this machine learning,
I'm going to use chicken bones.
Be fairly similar, right?
No, not really.
Not really. Okay, so what's
depends on what model you use. They'd actually. They've tested models, in the literature, they've tested these models against each other, Well, then so you actually don't know anything about this topic. I'm asking you this for a very specific...
Any literature, champ?
Because they're so... Dude, do you want me to link hundreds of PDFs that say, dude, we don't know?
I want you to link one.
Hold on.
Yeah, look, I'll add this in showing that machine learning can predict refraction.
So what? Machine learning is black boxes. We don't even know how it's doing the prediction. If you knew anything about machine learning, no,
that's genetic.
The machine learning is at modeling anything. You don't understand how machine learning works. So let's not talk about it until you know how machine learning works. Then there's nothing to talk about.
It's a genetic fallacy.
No,
isn't machine learning where the machine takes in multiple sources of data and then it comes up with an algorithm based off that data that would predict any two sets of data outcomes further on?
Okay.
Let's look. Machine learning, subfield of artificial intelligence that deals with systems that are able to acquire their own knowledge by extracting patterns. There we go. Extracting patterns to get new data. Great. So, have you found that study yet?
Yeah, I'll just read you a whole bunch. How about that?
No, just link one.
Where should I pick?
Have you linked one? Have you dropped one in voice chat yet?
Yeah, I got a link to like 10.
Well, I just want one, so link your best one. I'm going to just look at the top one anyway. Top one's going to be your best one.
So what? Just so I get the right thing, and I give you the right thing. What exactly do you want?
Show the difference that an observation using Snell's law refractive index versus Fermat's law refractive index.
I already did that.
Deviation.
I'm not doing it again. They don't use Snell's law, and they don't use Snell's law in any type of surveying, anything to do with
if they use Fermat's law,
terrestrial
why'd you ask
refraction. They
which
don't
one's
use
best?
it.
Why'd you ask which one's best?
No, oh my
Everybody knows
God,
that the
dude!
experts use Fermat's law, so why would you ask?
This is what you don't understand. There's models for terrestrial refraction. They involve temperature, humidity, CO2, yada yada
I've already
yada.
explained all this to you, you fucking idiot.
Listen, no, dude.
Yes,
There's
I did.
multiple
Remember
models.
10 minutes ago, I went through all the things that can impact refraction.
That's right. That's awesome. Yeah.
So
That's
I did
awesome.
explain it to you already.
Yes,
so this thing exists. So every single image you guys have of a flat Earth can be explained using refraction we know to exist.
Okay,
Experiment. Is that true? Yes or no?
Yeah, cool. No, it's not true. Okay.
Great. Give me one image that shows that the Earth is flat that can't be explained using refraction.
Using assumption, you mean?
No, listen.
Refraction. I just went through machine learning.
You just have assumption. You have no evidence that there is refraction happening on those days.
Hold
machine learning was able to calculate a refractive index.
They're not calculating anything.
Yes, it did.
No, they're not.
You're just assuming things. You have no values, so you're just assuming things. There's more values in the laser test.
Data goes in, it calculates, it comes up with an equation.
It doesn't calculate, it does. It doesn't come up with a fucking equation. You don't know what you're talking about.
When you get data and you run data
dude, machine learning is basically a lookup table, dude. That's basically what it is. It's a lookup table.
It
you have no idea what you're talking about. Dude, I got a degree in computer science. You don't know what the fuck you're talking about.
X equals C, depending on some variable.
It's not. They use gradient descent, dude. In this machine learning model, they use something called gradient descent. You have no idea what the fuck you're talking about. Stay like you don't know what you're talking about with reflection. You really don't know what you're talking about with machine learning.
Even if I don't know what I'm talking about,
I'm not going to explain it to you.
I can understand.
Look, I want to go back to these variables.
Someone who's been doing this for years.
I want to go back to these variables, right? So these variables that you say exist, it's cause refraction. Right? You think they exist because there's models that exist that use these variables to make predictions about refraction. Well, none of these models actually makes accurate predictions.
They do.
No, okay, where is that?
The Fermat's law. You just explained yourself that surveyors use it. Surveyors get accurate data over land masses, don't they?
I'm not talking about. So listen. Okay, so to apply Fermat's principle, you have to know the refractive index at any given point. How do you calculate that?
No, you can average
temperature, humidity.
Snell's law assumes that there's some set boundary, but Fermat's law can say that given like the known variables, you can average it out over a distance.
Well, they don't do averaging, but whatever. That's
what Fermat's law is. It may not be an average, but what it is it's going from A to B using a function rather than going from A to B.
Right. And so there's different variables that they use in these different models to model terrestrial refraction.
So
none are accurate. That's what I'm trying to tell you. None are accurate.
As a function, it would be centimeter 1 is 9 from 1, centimeter 8 is bloody 2, centimeter 2 is 8 from 1, centimeter 3 is 7 from 1. That's how the function would work.
Yeah. Great. Fantastic. How do they figure out what the refractive index is at any given?
Maths. I don't know much advanced maths, and I was able to explain to you how that would be.
You don't have to explain it to me. You're just you're trying to convince yourself of something, dude. You're not understanding what I'm saying, or you're deliberately being obtuse. There's a model. There's a model that uses these variables. So you're still going to talk over me again. There's a model that uses these variables, and none of those models make accurate predictions. These variables that you say exist, which cause refraction, to validate whether these models cause refraction, you need a model that makes predictions which are tested and known to be accurate. You don't have that. You're putting the cart before the horse. Where's the fucking horse? Where's the model of refraction that makes predictions so that we know these are the variables that matter? These are the variables that cause uncertainty or observation. These are the variables that we need to account for so that we can come up with a refractive index or a change in the refractive index from which we can make predictions with. That doesn't exist. And do you know what? It's been tested. So there was an experiment, this laser experiment across the Hawaiian Islands, and they took 3 lasers. And they went from one Hawaiian island to the other. And they did this experiment. They were measuring turbulence in the air. They picked up all 3 of these laser frequencies through their telescope. Then what did they do? So there was other research students there. So for his master's degree, he tried to model it. And when he applied the model of refraction, right? Gradient, standard US temperature, when he modeled it across this same distance using the same laser frequencies, he found out the experiment should not have worked at all. Because the divergence, because refractive index is wave dependent, right? You have, what the hell do they call it? Can't remember the name of it. Dispersion of light. That's where the wavelengths separate.
Why are you still talking? Have you linked a PDF about it?
Oh, I will if you want.
Yeah, of course.
It's going to make fucking spiral into oblivion, but whatever. So, so what happens is the spread of the wavelengths of the laser are greater than the width of the telescope. So when you model it, right, when you model it in this refractive index air, the spread, so you have 3 frequencies of lasers all starting at the same point. They spread out because not all of them refract the same. They refract differently. It's wavelength dependent. So they're spread out by some spatial distance. That spatial distance is greater than the width of the telescope. But somehow they picked up all 3 beams in the telescope at the same time. The only way that can happen is if there's no refraction.
How do I find this? How do I find this?
Hold on, I'm gonna post.
How do I
you want the underlying experiment? Yeah, hold on. So I'll find the underlying experiment. So this was there's experiments based upon. It's done by the Air Force. So the person that wrote this master's thesis, he tried to model what the results were, and when he modeled the standard, terrestrial refraction, using the same shit Bisgan uses, using the same shit Mick West uses, found out that, like it says, I'll read it to you. For the 150 kilometer path simulated, the rays are misaligned by about 4 meters.
Okay.
With respect to the point, the telescope's 3.4 meters wide.
And?
That means they should not have, if the refraction model was correct, they could not have picked up all 3 lasers simultaneously in the telescope. But they did.
What did they say about it?
I mean, what did they say about it?
What was their conclusion? What was their conclusion?
Well, see, they did the test first, and then after the fact, they applied the model, and then realized our test should not have worked. If they would have applied the model before the test, they probably would have never did it. They would have probably designed a different test.
Okay, so they came up with there is some variable or phenomena that we cannot explain. Is that what they came up with?
What they were testing was... Okay, so was it test
was their answer? The presented experimental results on intensity scintillation characteristics reveal complexity of the observed phenomena that cannot be fully explained based on the existing atmospheric turbulent models.
Yeah, so there's turbulence models, there's refractive index models, and he tried to use a mixed turbulence refraction model. None of those models worked, but the turbulence model, called a non-Kolmosov model or some shit. Can't remember the name of it because there's actually 2 of them. There's the non one and there's just a regular one. Anyway, so the turbulence model fit more closely than the so-called terrestrial refraction model. The terrestrial refraction model says that the experiment should not even have been completed because you can look at the simulation. He simulates it the same way Walter Bisgan simulates it, using the same methodology. So the fact that, and I have more stuff, right? So I have more. They've done terrestrial laser measurements using 2-frequency LiDAR. I can post that. And what they measured was the deviation.
What's that going to prove? What's that going to show? What's that going to show?
It shows that when they so-called measured the refractive index, right? They measured the angle of arrival of a beam of light of 2 different frequencies of light. And then they measure the angle, like how much deflection they are measuring, right?
Yes, but the argument.
And they're measuring 5 m. They're measuring a max 4 mgon deflection, which is equivalent to 0.009 degrees. So if you extrapolate out to 29 miles, 25 miles, that's 8 feet.
And
that's an 8 feet deflection at the max.
And
the laser, like ISO laser test, would have to be a 420 foot deflection, a 440 foot deflection.
And
you don't understand that the observation at Lake ISO is 2 orders of magnitude off the prediction, right? Even if you say you use 7.6R, it's 2 orders of magnitude off that prediction.
And what was their conclusion?
Dude, for FD core? Yeah, that does not fit the WGS 84 model.
Oh, you're talking about FE core again. They didn't add in any refraction, you fucking idiot.
And I'm trying to justify adding it in. So don't you get it? We're trying to justify adding it in without just saying, yeah, it exists.
The surveys use refraction.
Let's say we use 7.6R.
Surveys use refraction.
Surveys use refraction. How much refraction?
Do they accurately measure the surface of the Earth in distances?
For practical purposes, yes.
Great. Do they use optical measurements?
Yes.
Great. So why didn't FE Core do the fucking same?
We can do the same. We can use 7.6R.
Then do it.
We can use. So if you look, so I'll give you an example. We in the United States, different states build roads. If you look at the surveying manuals for the transportation departments in different states, they all use different refractive index ratios. They use different values for terrestrial fraction. So, for instance, in Massachusetts, they use 0.17. In Washington State, they use 0.13. In Europe, they use 0.13. So different places use different values. Listen, the point is, the largest value anyone uses is 7.6R, which is 0.166, right? So you take this 0.16 that they use in surveying, right? It only takes 5 meters off. You have to, and the value is 137 meters off. The measured value is 137 meters off, dude. So, okay, we'll give you refraction. We'll give you terrestrial refraction model. We'll go 7.6R. Yeah, now you have to make up another 132 meters.
I didn't say this FE.
Now we can go, okay, there's even double extra special refraction. We'll multiply it times 10.
Drop in the FE laser measurement link again. I'll look at it again using the highest and lowest refractive indexes.
What does that even mean? First of all, you just quoted surveying. They use a 7.6R value.
Stupid rambling way. If we were to add in the standard refractive indexes into the FE core measurement, it still would.
Yeah, the ones you just appealed to, surveying. Those are the ones you just appealed to. You said surveying, they use refraction. That's what they use. They use 7.6R.
Big fella, if you add those into the FE core data, it still won't explain the data. Is that what you're trying to say?
I'm saying, if you add that value listen, I'm explaining it to you. If you add that value into the data, it only moves the laser down 5 meters.
Okay, great.
You have to move it down 137 meters.
The FE core thing again. I'm gonna download it. I'm gonna go away. I'm gonna do the maths. I'm gonna come back. Okay.
Yeah. Okay. Fine with me. I want you to keep in mind that they didn't this isn't a one-off. They did it 3 weeks apart. So make sure that you read the dates.
Don't care if they didn't add refraction. I don't give a fuck.
You don't even know why they should be adding it, other than somebody told you they should add it.
No, I know why they have to add it. They have to add it because as light moves through a medium, if there's any change to that medium, then the angle of incidence changes.
And that means what?
And that means that the light can make things look further up or further down.
Okay. Yeah, you're claiming that. But you're claiming that. But what's the evidence? Dude, that's what you don't understand. You don't understand there's a difference between claims in
You ever
evidence.
opened the fridge, mate? Have you ever opened the fucking fridge and looked at it? You cold air when it hits the warm air and things get all goofy behind it.
Well, that would be evidence.
What about experiments? But there's one where some dude like pours cold water over, or I think it's liquid natural gas over a propane tank, and you can see some, I don't know, colours that you couldn't see before, some bands of colour.
Thank you for proving. Thanks, you just proved flat Earth. Thank you very much.
Affecting what you see.
Yeah, that's great, dude. Do you know what that proves? Because you have to use this butane. Listen to me. Because that proves that you're applying Listen, you don't get it, dude. Butane has a okay. Can I finish? Can I finish? Can I finish? Can I finish? Okay. So the refractive index is butane, by the way. And the refractive index of butane is 1.33. Right?
I don't care. I don't care.
So check it out. The fact that you have to use, listen, the fact that you have to use an extreme, non-physical, unequivalent demonstration to simulate what you say is happening all the time demonstrates that it's not happening all the time. The fact you have to use butane to show it to happen demonstrates that it's not happening all the time.
It happens with cold air. It happens
with
cold air.
Yeah, with cold air, but that has a temperature gradient of something like 70 degrees per centimeter. Is that physical? Do we experience that in the real world? Do you ever have your feet get frostbite while your knees were burning off? I didn't think so. The fact you have to use extreme examples of demonstrations, non-physical to what we experience in everyday life, proves that it's not happening.
Oh my God, that's because the demonstrations are done in people's houses, you fucking moron. You fucking idiot. If you're going to demonstrate something in your house, a very small area, then you have to use extreme refractive conditions because you can't have the massive change over a long area. It's numbers, you dumb cunt. It's numbers.
Oh,
what numbers?
The language on you. You blow your father with that mouth?
Oh my God. So
what numbers?
Say, I want to test something in a very small area. Okay, and I want to test some variable that usually happens over a very long area. I have to make that variable much bigger in the small area to make sure that I can observe that variable in action. Because over the very, very, very long area, that variable can have very insignificant changes, but because it's such a long area, those insignificant changes can cause a massive change over that long area. I'm explaining this to you like a child because so far you've shown that you may be a child.
This is actually pretty humorous. So what you're saying is,
look, here's a video.
We have to scale down the experiment to demonstrate that the phenomenon, which should be happening all the time in the air, is actually possible. And to do this, we need extreme conditions. But the underlying phenomenon, you can't actually demonstrate is happening.
Extreme conditions, just people show that it's possible using extreme conditions because they're doing it in their little house.
But they're not equivalent.
Of course they're equivalent. It's just scale, mate.
Okay.
If I want to make a square, I can make a square 1 centimetre by 1 centimetre or 1 mile by 1 mile, but those fucking squares will still be square.
Okay. It's not equivalent, and the scale's not equivalent, okay, because the refractive index of air, I'm going to explain to you why. I'm trying to explain to you why the emotional child.
Fucking trains are
irony of you calling me a child with your spasming, dude. That's hilarious. Anyway, so the refractive index of butane is nowhere near equivalent to air. Air's refractive index changes. Yeah, you don't give a. I thought it was math, dude. I thought it was numbers, but now you don't give a fuck.
Past butane onto air, but you're stuck on butane.
No, I'm going to cover them both.
You consider anything that goes against your biases.
So I'm going to cover them both. See, don't presuppose what I'm going to say, dude.
Well,
I'm going to cover them both.
Don't talk about butane because I don't give a fuck.
No, you don't give a fuck. Okay, so let's talk about the air. The temperature, the extreme temperature gradient, right, that you're demonstrating. So I've seen the dry ice demonstration. The refractive index of CO2 is not the same as air. And then I've seen. I think they use a cold plate or something like that, or ice. I think it was Mick West used ice. Was it Weiss? What did he use to make everything cold? Was it turbulent air?
No, he didn't use Barry Weiss.
What was used to make the temperature gradient?
I don't know, because I'm not obsessed with people that do these experiments like you retards are.
So you cited an experiment that you don't even know what happened. Great. Let's go
one
with
that
that.
I've watched. I cited an experiment that I've watched, but I don't remember the people that did it because I don't give a fuck. Look, I found.
So what if they use dry ice?
Would you like to see that? Let's look at the Mick West
What if
one.
they use dry ice to
I did. I found the one you wanted. You wanted me to talk about Mick West, didn't you? Because you have pre-prepared.
No, I don't care about Mick West. He already got smashed in here. You can fucking listen to the video on the YouTube channel.
Yay, there's Mick West. I finally found the thing you were talking about that I wasn't.
I don't care about Mick West. I'm asking you, if you don't know the details, if you don't know the details of the experiment, you don't know if they use CO2, if they use some equivalent. You claim they're equivalent, they're just different scale, but you don't actually even know that. I'm asking you, if they use CO2, why did they change the air? I'm trying to figure out the
iron.
See, you make claims that there's no evidence for. That's the hilarious part. You just keep,
What claim?
You claimed that these demonstrations are equivalent and they're just a change in scale. So I'm asking you details about them and you don't know the details. So you're just talking out your ass.
What detail do you want? The guy put up an iron.
What did they use to cool the air? What did they use to
laser changed it?
What did they use to cool the air? What substance? How did they create this temperature gradient?
Nothing. They warmed up the air using an iron.
They warmed up the air using an iron? What?
Are you just going to repeat back with a dumbfounded?
I don't understand what you're. I don't understand what you mean by they warmed up the air using an iron, like an iron for ironing clothes. Iron, like
you
what?
Don't seem to understand anything. I linked the video.
Because you suck at explaining yourself.
You know, an iron, like you iron your clothes. Yeah, it heats up the air. Look, here's one of nice wavy air patterns in front of a heater. Why would that happen?
Turbulence. It's called sensible heat flux.
Amazing.
Yeah, it's called sensible heat flux. Yeah. So, like when air gets hot, it goes up, right? Right? It tries to equilibrate and it moves around. It's like why you don't survey in the wind. So there's something called the Fresnel effect, where a medium that's in motion will deflect light in the direction of the motion.
Oh, okay. So there is refraction, deflection.
That's not refraction. It's a completely different thing.
So did they look at what the wind speed was over the water in the FE core experiment?
Yeah, I'm pretty sure they did. I mean, it's on like they took pictures of the meteorological
Anyway,
stations.
I'm out of here. My earbuds are about to die, and you seem to be thicker than a brick, my son.
Yeah,
hypothesis in science, buddy.
Oh, does that qualify as a wig, bro? I'm sorry to everyone that cut up. I do not want to let him out of that. Otherwise, we're going to be looping on that shit forever. I'm sick of this guy. I'm sick of looping with this guy.
That counts as a wig with the earbud still attached.
Ew. How about the ear still attached? How much glue did you use on that wig? Listen, this is, to me, these refraction claims. Like, I'm so sick of it just being like a foregone conclusion. You didn't include refraction. You didn't account for refraction. Why should we? Give us a reason why we should. Oh, because everybody else is doing it. That's not an argument. Surveyors do it. Yeah, so what? And? They're measuring 50 meters at a time. The uncertainty is like 2 millimeters. Do you think that like if they don't use refraction, it's like, oh my God, now the fucking road's all fucked up. It's a 1,000-mile road and now it's messed up because we didn't account for refraction. I mean, come on, man.
Dude.
Get serious.
Did they account for refraction when they used the microscope on that fishing line?
Dude, that's somebody that's like, have you ever done asphalt AI?
Not really, no.
I
Cement,
have,
though.
when I was a kid. So I've done asphalt. I wish Mike was here. Like, you're precise, but you're not that precise. It's fucking asphalt, dude. It's like,
yeah, exactly.
Fucking not measuring to like, oh my God, we need to account for refraction of the road, man. Oh my God, like now the road doesn't work. I mean, get real.
Oh, I've done sidewalks and stuff and foundations, but yeah, same principle.
So they only use the geodetic surveying so-called techniques for practical purposes in road work. They don't use them. And it depends. It depends on whether it's an interstate highway versus, state road versus a city road, right? Depends on whether they're going to use a state plane system versus like the geodetic system. And the geodetic system is going to has to be long. And like any error of not using refraction is going to be so negligible, it isn't going to matter. They never like built roads and were like, fuck, we built this whole road and didn't account for refraction. No wonder why it's messed up. No one has ever done that. That's never happened.
Yeah, you were trying to tell me. I thought that the point that I wanted to jump in that was annoying was that he was trying to say boundary wasn't like the part he was missing was that to spell law it's two mediums.
Yeah, well, I went over that. And, like,
that's the boundary.
He denied it. That.
And I posted. It's like because I would have pointed into the screenshots of Snell's law. I'm like, what's that?
Look, I really didn't want to go into these rabbit holes with him. I just wanted to point out that there was, like, I was laser focused on one thing. Point out that he has no justification for including refraction in any calculation of anything, ever. That there's no actual justification for it. There's no, like, oh, we have a model, and this model requires refraction to make it unfalsifiable, but other than that, there's no reason to have it.
Yeah. Well, there you go. That's the rationale.
Oh, you got him so hard, AI, dude. You got him to admit we're making our model unfalsifiable. Like, that's pretty much what he admitted. That is just perfect.
It was like that day when me and Kiwi were going through, and I was teaching him how to use the Bislins, and the refraction slider. I thought it went up to 60 million radius, but it actually goes up to 60 billion radius.
Oh shit!
He's like, "Oh, dude, what's these extra 3 zeros here?" And I'm like, "Hold on a second." I resized my screen, because sometimes it cuts it off if you have like 20%, 70%, whatever.
Yeah.
And then I saw the rest of the numbers, the rest of the zeros. I'm like, "Damn!" I'm like, damn.
Oh my God, Earth's the size of the solar system. Actually,
well, one of our
galaxy, right?
Yeah, so one of our friends asked a question, which is, how does he explain the Canigou shot? Well, lo and behold, this is what me and Kiwi were looking at. So we went and we did the slider, right? And we did this calculation for how much we would need to get to the Canigou shot. Now, check this out. The number of that value was only like 0.003 different than the category that you can click that just pre-calculates what's called extreme refraction. So let that sink in. And Walter Bislin's calculator, when we did it, and by the way, it's recorded, so if it was changed, there's proof still there. He literally labeled extreme refraction the exact amount of refraction needed to defeat the Canigou shot, proving the point that it's just an unfalsifiable ex post hoc excuse.
Yeah, that's the same thing he did with the Black Swan. That's why I brought it up, right? So he created this piece of software, and then he manipulates the variables until the piece of software looks similar to the image, and it doesn't matter what the values say. The values can be non-physical. It doesn't matter. So in the Black Swan, unlike all the other simulations, he tilts the camera up a tenth of a degree. I don't know why. If you put it at regular degrees, it doesn't match. So he takes the camera. So he's got all, he's got the tabs of different like observations.
You mean level?
Yeah. So he tilts it up 1 degree from level, or
right? Yeah,
from level.
Makes perfect sense.
Yeah, but he doesn't do that for any other observation in his little tabs of Soundly's Bridge, like Pontchartrain, like he's got all these little tabs, right? So This is the only one where he does this, the Black Swan. He tilts it up. And then when you look at the ray trace, the rays flipped it over. That should make an inverted image. When you have ray tracing paths, right, and then the rays cross over, like the top rays become the bottom rays, and then the bottom rays become the top rays. That's an inverted image. But when you look at it, it doesn't invert the image. I don't know if he did this intentionally, or it's an error in the software, or a combination of both. It's not a bug; it's a feature. You know what I'm saying?
Well, if there's a point of inversion, your lens would have to be there in order for it to be an upright image.
At least he has a little graph where it shows where has the variables, and then it shows like this crazy like. It has a graph of like the variables for like the temperature, altitude, that, right? So that is just insanely all over the place. So if he had to fiddle around with the variables until he got something close enough, right, to what the black swan looks like, but didn't think past like, oh shit, these rays are inverted. He doesn't care about that. As long as the software comes out the way the image is, that's all he cares about. That is some bullshit, dude. Like you couldn't get away with that in like ninth grade.
It works. It works.
It fools people like this guy. You know what I'm saying?
So it does work.
Yeah, it does work.
Dude, once you're told that there's like he said, a greater than 50% probability, right? When you apply the Snell's law or whatever, that the horizontal rays will remain horizontal, right? That would be an impetus for you to maneuver the thing like at an up angle, right? Because if you just have the rays going straight and they're not passing any variability, they're just going to stay straight, and there's going to be very minor variability. But in their worldview, they have infinite variability of paths probability. So they can just pick and choose any paths they want. And then draw lines like as if they're heat-seeking missiles shooting you straight in the eyeball. And again, that just makes their claims unfalsifiable in principle.
So I'm going to take a screenshot of this shit.
But by the way, all his claims also backfire on all optical observations that the globe makes, because the scrutiny that he demanded of the flat Earth side was not applied to any of the globe Earth observations.
Yeah, like, did you measure in the middle? Remember that? We got to measure in the middle. He don't. But
Yeah,
the middle is where you're going to
problems.
actually have to measure it, right? You're not going to measure it at the edges.
Yeah, all the models, all the refraction models are based on measurements that were taken at some point, not current measurements of the current conditions, anything like that. And then it's like you can stretch those boundaries, so it's just used to fill in the gaps to make things match.
Yeah. Well, the Itchel test, they did measure in the middle by hitting the panned targets. And they demonstrated the variableness of whatever alleged refraction would have been there. Well, it really just all about the bias that we already know the Earth is a globe. This observation doesn't fit geometric wise. Therefore, the light must have curved. Oh, well, what model did you apply to know how the light curved? Well, simple. We just plotted out the geometric points and then applied a circle, and then we said this light had to follow this trajectory to get to you. Therefore, it did. It's the most ex post hoc bologna sandwich of rationale.
Doesn't the infrared observations just throw the refraction argument out the window anyway?
Yeah.
Not having a globe radius to refract does that pretty well too.
Yeah, it's just they make the claim that all the light is bending around the globe, so it appears flat, and so we can see 10 times further than the geometry in the black swan, and they just bend everything to make it match. But if that were true, then we would be able to just use infrared and be able to see that the horizon is always closer in infrared. Do we see that in real life? I don't think so. All long-distance photographs in infrared that I've seen taken close or with short duration between a visible light picture show the infrared actually seeing further. So I don't I don't see how they can get away from that.
Dude.
Well, that was.
Yeah. Hold on. I gotta show you all something. How far is the Black Swan? How far is 10 kilometers? Or 10 miles in kilometers? That's
16.
Okay, 16. Yeah, I should have known that. 1.6. Should have been able to do that in my head. I'm sad. That's just sad.
Well, that's just the next greatest whole number after the demarcation point of the rig. It could be much further than that.
Yeah, how interesting would it have been to see that Black Swan taken, one with infrared and one with visible light? Like, how far would we have seen the beach of the island that's back there? I don't know. It's hard to see because it's the light is so diffused near the horizon.
Look how insane this is. This is Bislin's ray trace. These are the path of the rays. Look how just insane this is. This is what it takes, right? These extreme situations as evidence for the globe, right? That there has to be an extreme, and that's the only way that they can even approach what they're claiming is happening all the time. That's the thing, is you're claiming that this is the general condition, right? That we see too far, and we have to apply this refractive index, this standard refraction all the time. And occasionally it's a little bit worse. How come it's never a little bit better? Oh, that's when ships go over the horizon. Well, how come refraction doesn't make it look even closer still? How come the refraction doesn't make it look like an extra curvy ball?
Exactly. Or make the horizon appear like at 30% in the top of your viewpoint.
Yeah, why doesn't it make the horizon appear like a mile away when it should be 1.2 miles away or 500 feet away or right in front of your face?
How come they can't even show a picture that even matches their claim standard?
Yep.
Good question.
Dude, why does this picture you post have a big yellow block for obvious contrast, like it's flashing at me and it says custom refraction?
That's I don't know why you're there bragging about that.
I know.
So the way I figured out that this was tilted, right? These rays are tilted up. I'm like, man, look at all those rays that are all really close together up top. I mean, that's kind of weird, I'm thinking. And I'm like, he must have did something. So I start clicking through the tabs, and these rays are tilted up, right? So they tilted the camera up, so the rays that are entering, so what you're taking is, so what they're doing is, right, they're taking the image, right, and they're taking one pixel in the image, and they're moving it across the grid, right, and moving it up and down based upon, the angle of change of the refractive index, and then they're projecting it onto the image that is going to be presented on your screen, the one that, quote unquote, matches the observation, right? So there's just moving this pixel up or down relative to that. But apparently that must be clamped because they're not moving it into their correct actual location. But in order to do this, they had to tilt the projection plane. This is being projected on. He had to tilt it back to get the geometry, the shifting to match the so-called black swan, and it still isn't even a match. You know what I mean?
Yeah.
It's A for effort, but not quite.
It's also if you look at like your image at like 2 minutes after the hour, like if you follow those rays, why like on the globe, you'd be seeing the ground like up in the air, really high up in the air.
Yeah, it's all messed up. Like this is I just use this as an example of like post hoc, right? It's just completely post hoc. We're going to sit here and fiddle with the dials until we get it to match, right? And we're going to make, refractive indexes that are absurd and not seen in nature. Like dogsaregods was citing, right? We're going to do tests that aren't seen in nature to prove that these phenomena exist in nature. No, dude, that's not how it works. If you have to do an absurd test, then that phenomenon does not exist in nature because you're going outside the natural order to demonstrate that it can happen at all.
Yes, a roided, jacked up, serum-induced, Neanderthal can lift, 2,000 pounds. Therefore, I can lift 2,000 pounds. Therefore.
Yeah, everyone can do 2,000 pounds. 2,000 pounds is happening all the time. People are just like picking up 2,000 pounds. And here's I didn't want to point it out because I didn't want to go down this rabbit hole. Kept saying you're using a genetic fallacy. Literally, he was doing the exact same thing he was complaining about. Remember when he started talking about epistemology? Right? And he because what he said was a genetic fallacy was because I don't know how somebody did something, that means it's not true, and that he used it for epistemology. So some people had to come up with the epistemology, right? So they said that this epistemology is correct, and that we don't know about it, therefore it's not true, right? He did the exact same thing, the exact analogous thing, 5 seconds after he complained about you doing it. Or he complained about Miggy doing it, quite honestly. Yeah, it was Miggy. So, I mean, it is what it is. I just want to illustrate that, like, that was my only laser focus. I want to illustrate there's no rational basis for applying refraction just because. Right? We can say other phenomena exist, and we're not just going to willy-nilly just apply them to, like, observations. So you could think about it like this, right? So we have diffraction, right? So we can model the path of light as if going through a shitload of holes, right? There's an infinite amount of holes, and we can use this diffraction model. There's an infinite amount of holes between point A and point B. And then we can just say, well, the light's just all over the place because, it's actually, that's not even a real image. That's just like a hologram of an image because you have all these little, you can model the air as like a hole because the light's going between the freaking atoms, right?
All
so that's
the little
just
balls, yeah.
Exactly. Yeah, so it's all scattering and diffracting, and so when you actually see it, it's just a hologram of the image because of wave interference. It all just comes together and coalesces in your eye, and and we have a model for this, so we're going to apply this all the time on why the Earth, ships over the horizon is bullshit because we have this diffraction model. Okay, so we have a model. It doesn't make predictions, but we're just going to apply it post hoc to every single observation. Nobody would accept that, and they should not accept it because it's bullshit. And this is what these guys want us to accept. This nonsense.
Wait a minute. Did you just say that every space between a particulate is an aperture and therefore compounds diffraction? So you have an infinite diffractive path model, which essentially would become the same thing as their infinite refractive path model.
Yeah.
So you could just pick any path you want, and as long as you can trace that path from the source to the observer, then you can validate your claim.
Yeah, I mean, we could all play the same game, right? We can say refraction makes the Earth look, the Earth look like a globe, right? Like, I mean, we could say anything. That's the whole point of unfalsifiability, is that the underlying claim can prove both propositions. Well, not prove it, right? Or you can be used as evidence for both propositions, right? We can claim
either one.
Yeah. So we can claim refraction makes the Earth is actually flat, and when it doesn't look flat, that's refraction. And and they can claim the Earth's a globe, and when it doesn't look like a globe, that's refraction. It makes it unfalsifiable. Well, how about there is no refraction, and that we're just misapplying it? Like the optical phenomenon that we're seeing is not refraction. It's turbulence, or internal reflection, or any number of things. The point is, because the refractive model can't make accurate predictions, that's actually wrong, and it has to be, because they've been trying to figure it out for 150 years, and they still aren't any farther, right? And to the point, man, I wish he was on here. I should have asked him, if they have a predictive model, why are they using AI? What's the purpose of that? They have a predictive model. That's redundant. Why even use AI to do anything, right? We have a predictive model. We can just take a picture, and we know what the refractive index is. You understand what I'm saying, right?
If I was gonna feed my AI, right, what I would do is I'd take a bunch of pictures that have supersedery information according to globe geometry, feed them with that presupposition that the bottoms of things are cut off because of globe geometry, and then you have the squashing effects, right? And then I would tell the AI, create me a model that traces the path of light that assumes globe geometry from these images, and then it would give me all this, spaghetti string nonsense, right? So now they just have an even better Earth curve calculator. So you say, oh, look at this image of a mountain 500 miles away. Oh yeah, well, look at this spaghetti string.
Well, see, this is I didn't think of it at the time. I should have did this. So you could have took this AI, right, and fed it a model of gravity, right? So little g, not big G, right? So that when the mountain is displaced down, that means there's a greater acceleration, and you could put in the equations for it, you put the mass of the mountain and the acceleration of gravity at that particular spot, and you would just say, okay, what's the acceleration of gravity if the mountain's in this location? What's the acceleration of gravity if it's displaced this much, right? And then you could feed the AI a bunch of data, and the AI would say, yes, it matches. When the mountain's here, the acceleration's this. The mountain's here, the acceleration's that, right? And you could just come up with, because you're making correlations between one model in the AI, in the image, right? So you have a model, right, the equations of gravity, and then you have the images, and the AI is making a correlation between a particular image and a particular value in the model, right? But it has to start with some reference location. And as long as it has that initial spatial reference, right, then it can measure the displacement of the pixels relative to that. And so you have a reference, okay, the image is here, the acceleration of gravity is this. Now, we're going to show you all these images. How does the acceleration of gravity change based upon the images? And you apply the vertical displacement is because acceleration increases. And the AI just figures out what's the correlation between those two. That's what I was trying to tell them. You don't understand what machine learning is doing. It's just making correlations between two pieces of data. But you have to start at some reference, right? You have to start at some reference location so it knows how to make the correlation. And you could have literally stuck in any mathematical model of any phenomenon and told it programmed the AI so it said, oh, if any causal mechanism for the displacement of the pixels, right, up or down in the image.
Yep.
You literally could have just said anything.
I choose women's feelings about the color blue presently.
You could actually do that, which is kind of scary.
So the more women who are happy with blue, the more refraction is present.
You could have correlated to the menstrual cycle, how many times freaking someone watches clown porn on Pornhub, you could have done anything. The people don't understand AI, they're caught up in the hype, this thing's thinking. It's not thinking. It's not doing anything. It's just making a correlation and giving a probability on how two particular data points are correlated within their data set, right? Within the data set that it was fed. Because when you start increasing the size of the data set, values change, right? Or if you decrease the size of the data set. So it reaches like different quote unquote conclusions. It's not reaching a conclusion. It's just It's just a giant fucking lookup table.
So long story short, how this all works is you have a distance between point A and point B. You have the assumption of straight line rays, right?
Yeah.
You can't see the bottom of something, so you shift the rays down. You then assume a curved Earth horizon is blocking it. Then after that, when you see any observation in the real world that supersedes that, you then say, oh, well, maybe these straight line rays aren't straight, they're curved. And then you just draw curved lines. And you notice how all of this just occurred on a piece of paper and not actually out in the real world.
Yeah, amazing, man. It's amazing what you can make up in fiction. I mean, there's no difference between writing down a bunch of refraction equations and saying that's terrestrial refraction and that's evidence of it, than me like writing a book of fiction about wizards and elves. There's no difference. It has no relation in the real world.
What always got me is this idea of curvilinear graduations, right? And how they would apply these apparent straight line redirections of the light, because it seems like they would just be driven off rather quickly if you assume any kind of curved boundary. So you almost have to go into this infinite boundary. Do you remember that refraction model where it was vertical gradations from the target point to the observation point? And that's how you could get it to the light to go with, I think with Snell's law, maybe.
Yeah, well, yeah, what they use, like, yeah, it's like, I'll pick graphic. I mean, there's the best really way to just show it in images. Wherever the hell it is. Yeah, so I got, refraction. So we got this. So this image, right? So each one of these, this is how you would model Snell's law, right? You'd have a bunch of layers like this. If you look in live stream voice text, you have a bunch of layers. So it's like how many layers do you want to use? Basically, you're like, how cheap is my computer? That's what you're asking, right? How long do I want the simulation to run? How cheap is my computer? And as you start adding layers, right? Like, it deflects more because it has like this set value. It's not like a smooth curve, and it'll approximate a curve, but that curve isn't going to look like the curve of the Fermat's principle. And like, I don't know what he didn't understand. Like, it's a divergent value, right? So, say you compare them at like 110 kilometers distance, the divergence is going to be small. But if you have a longer and longer and longer optical path, the divergence becomes larger and larger and larger, obviously. It's not like a ratio. It's not like they stay like in this ratio. It's only 10% different forever. No, it's like the difference like increases over time. The divergence becomes greater.
Right, but
because the error accumulates, right? So the error, like if you were going like, okay, this ray would hit at 10 feet versus 15 feet. Well, as you move down, right, because that angle is continuously changing, right, and they're not continuously changing the same, that difference compounds over time. Right, so now one ray is like shooting up at a 45-degree angle, and the other one's only going up at a 10-degree angle after some distance. Well, now when it starts like curving some more, it's going fucking straight up, and the other one's going up at 45 degrees. That's a huge difference. That difference went from 30 degrees to freaking 45 degrees. Right, so like I don't like he just didn't. I don't know if he don't understand or what the issue is. I don't think he wanted to understand quite honestly. Probably how I should have characterized it. He didn't want to know.
Yeah, well, he did call you a cunt, so...
Yeah, well, he could be right about that.
Right, but those are still horizontal gradations, not curvilinear gradations.
Yeah, yes, exactly. So what they're saying, like, with calculus, like if you take an infinitesimally small straight line, it'll approximate a curve and yada yada yada.
For what?
You're hot, way mixer. You're hot, dude. Your mic's hot.
Also note that, like, there's a specific angle here. They would require all these specific angles and boundaries to get things around the ball.
See, in Snell's law, you have to calculate where the light intersects, the angle that it intersects the boundary, and then it bends towards the normal. So you need to know 90 degrees from that. That's what the normal is. The normal is in mathematics is called, it's 90 degrees from a boundary, right? So that's the intersection point. So that normal in a gradient keeps shifting, right? So you have to keep calculating that over and over and over again. And then, like, to get the angle of incidence at the boundary, and right, like, one location isn't going to be the same as some other location, which is why they just use Fermat's principle, because it's just simpler. It's simpler, more accurate. It's just like, why would you use? They just don't use it. So, like, saying it's this whole shit about, like, whether the boundary is physically real, not in the application you're using it for.
Well, look at my picture there, man. Look at that picture. You see what I'm saying?
Yeah, man.
See where I'm going with this?
Yeah.
If you got curvilinear gradients, bro, your little 180 degree summation is going to take all that light and just drive it into the ground.
Yeah, man. It just ends up a mess. That's why they don't use, like I said, that sound redundant. Why they don't use it. Like, they don't even think about using it. They know it doesn't work. They know it, like,
right,
but for a long time.
And does nobody remember that vertical gradient thing where it says this is the way it would have to be, and it shows, like, it's black and white, and then it's got vertical columns, but they're splayed out in radials, and then it shows the path of the light going through? Yes,
oh,
right
that,
there.
yes, yeah, Trace, you're the man.
Yeah, like, that's what you need to chart it out nicely and spicely. Otherwise, you get my picture.
This is wrong. Culver say this is wrong because the gradient is radial, right? It goes up from the center.
Right, but if you have a radial, like, curvilinear gradient parallel to the alleged curved surface of the Earth, then in my opinion, you get the nonsense that I drew.
Yeah, but your nonsense supports the globe, so it's obviously correct. Actually, it doesn't support the globe. I don't know what that supports. That supports insanity, I guess.
Concave Earth, welcome.
Oh, fuck, dude. banning you right now, man.
This was an elaborate troll to get you all set to the concave side.
Gandalf has entered the chat.
Wait, what's concave Earth?
Exactly.
It's a mental illness, man.
It's a joke.
Concave Earth is very simple. So go to your house or go to a store and look at a globe, and you're seeing a ball with everything on the outside of the ball. Now just imagine all of that is exactly the same, but on the inside.
Yeah, all the math works too. Yeah, the math works perfectly. You just add a negative sign to all the values.
I was imagining like a bowl.
It is a ball, but you're inside the ball on the inner surface.
A bowl, like we
a bowl? Oh, no. Oh, I mean, it's two bowls upside down touching each other, and you're inside each bowl.
Well, there is a model of like that. It's, what is it called? It's what the Brazilians did.
Oh,
what's the difference between hollow Earth and concave Earth?
Hollow Earth's the globe, but it's hollow on the inside, right? So there's like lizard people or whatever's in there. And then like concave Earth is where you're like, I don't know, held to the inner surface of a hollow sphere.
Yeah, it's basically concave Earth is you're on the inside of the sphere right now. Hollow Earth is like there's like a concave Earth on the inside of the sphere. Although there's also hollow Earth conceptions under like many different other conceptions. It's just
there's a bunch of hollow Earth ideas. Like they're pretty varied. Some think it's subterranean, right? So that there's subterranean stuff. Some think there's there's a whole land, like a different, complete ecosystem. You know, so like
the concave also has different conceptions. Some of them are just like our ball wrapped on the inside, so we're just the same sphere, but just we're on the inside of that sphere. Others are just like it's a flat spot on a gigantic sphere, and there's a ton of them.
Yeah. So concave Earth versus globe Earth is globe Earth thinks your feet, someone is antipode to you, your feet are pointing at them. And in hollow or concave Earth, if you're antipode to somebody, your head is pointing at them. Your heads are pointing at each other. They're at the top of the inner sphere and you're at the bottom. And what's in the center, the thing called the stars, right? The night sky, is also a giant sphere that is too big. That it's so big that you can't see that it's a sphere, right? So it goes all the way to the horizon. And that, like, when you travel, right? So if I, quote unquote, fly, do they even have a word for it? I can't say fly around because you're not going around anything. So what happens when you go, quote unquote, around the world in a concave Earth, what do you call it? Is there a word for that? Like, is there like a mathematical term? Okay, so so you can't you go around a ball, but if you're inside the ball and you go like you're on the inner surface and you like trace a path on the inside, that can't be going around.
Yeah, it's called centrifugal navigation.
Going within.
Just like skimming the crust.
We call it in round. We call it in round. You go in round or
in round.
Okay,
I don't know, man. I'm grasping at straws here, man.
So the Brazilians called theirs convex Earth.
Yes, that was it, convex Earth. Yeah.
I'll show you the picture. Since you're since you're gonna love it.
So also about the concave Earthers, they're led by someone. Did he pass away, Lord Stephen Christ?
Well, if he did, he certainly didn't rise again.
Well, I mean, he's like a paranoid schizophrenic perennial jail inhabitant that kind of like it's like cell Earth, concave Earth. So what they think is that the sky is a big giant ball that you can't see the edges of, but like when you walk around the Earth, you are basically walking around this ball thing. But the sky is projected from the Great Pyramids in Egypt. It's called the Black Sun, right? So the sky is the Black Sun, and the sun and the stars and everything are within it. So when you look at the stars, you're not looking out, you're looking in. Everything is backwards. Like I said, all the math is the same, just add a negative sign to all the values.
Yeah, but there's a big problem with negative curvature.
What's that?
I'll show you. 1 second.
Oh my God, that image is so cringe, man.
Dude.
That really is, man. That image is mad.
Dude, it's mashed potato Earth with blue gravy and a little parsley.
I know, man. There's some chives in there. Is that chives or parsley?
So a sphere with negative curvature. What is it going to look like? You guys ready? Hold on. I got to get the photo. Download. Now, this is actually very relevant to what we were talking about earlier, which is the catenary curve problem. Because a sphere with negative curvature forms a catenary curve. If you take the two ends and flip them around, so you inverse the negative, and then you end up with a catenary. Here it is.
That whole debate was a train wreck, man. 100%. That's where I live, man. Ouch.
That, my friends, is a sphere with a constant negative curvature.
In 2 dimensions? How many dimensions is that?
3.
You sure there isn't a 4th dimension I can't see?
I don't know, maybe.
That's a black hole.
Yeah, that catenary curve thing, that was a train wreck, man. That was an absolute train wreck. Like okay, they pulled the string taut. Well, there's a catenary curve. Well, it was negligible. How do you know? Did they measure the string? No. Like, what?
How long was the string?
He said it was very slight, so there was curvature of the string.
Right, so he couldn't answer how long the string was, which means you don't know how much of a sample size it was of the overall structure, and he couldn't tell you how they affixed the string in free space, meaning, did they just put 2 sticks in the ground and attach the string to 2 sticks? How did they make sure those sticks were level to each other? Because the whole point was, he claimed, is that they were referencing the curve of the Earth based on calculations that they were applying to the string, and then they were using a string as a reference. That literally makes no sense, unless you can tell me all the parameters of how the string is oriented compared to the size of the overall structure and at the 2 points, the 2 ends.
Well, let me talk about how much of a useless exercise that whole thing is, what they did. Now, let's say they did everything they said. They're going to make 2 tanks. They're going to make a tank where they think there's curvature and a tank where they don't think there's curvature. And then they're going to stick a toy model boat in there and simulate the boat's action through water on the ocean. Right? And then they're going to build a boat. And then they're going to stick the boat in the water. Right? They made one with the tank designed one way and one with the tank designed the other way. Do you think there's going to be a fuck bit of difference between those boats in the ocean that you can tell? Oh my God, this one's going 13.0001 knots faster. You wouldn't be able to tell the difference. It would be so infinitesimal because when you actually model fluid dynamics, the functions are nonlinear, so they normalize them. So there's errors that are greater. There's uncertainties within the mathematics that are greater than fucking their tolerance of their measurements by probably 100 orders of magnitude or thousands.
Yeah.
So the Navier-Stokes equation, which is about fluid dynamics, is a Millennium Prize problem. And if you can figure it out, if you can prove it, then you can have $1 million. It's considered the hardest one out of all of them, other than the Riemann. I mean, the Riemann one is thought maybe provable. The Navier-Stokes equation, because of the nonlinearities, is probably not provable, whether it's valid or not. But they use it to model shit within a range, right? They just basically clamp the infinities, right? Normalize the infinities, and that's it. But what I'm saying is that they didn't need to do that. They didn't need to do that. They didn't need to do that like engineering adjustment, because for practical purposes, he kept saying it worked. It worked to do what? Yeah, they made a tank, right? And they stuck a fake boat in it. Yeah, it worked. They didn't have to account for curvature to make a tank full of water and stick a boat in it. It makes no difference, right? Because what were they designing? A yacht or something, right? A racing yacht? Okay.
Well,
I don't understand what even the purpose of this was, because it seems like just doing it to do it. We got to publish a paper. Let's do this bullshit.
Assuming a curved water level and lining stuff up to it worked. Would it not have worked if they hadn't assumed the curve that they never measured or verified? What's his point?
Yeah, that's what I'm saying, man. That's exactly what I'm saying.
Yeah,
they like when they built the boat, when the boat like sank because they didn't curve the fucking tank 0.06 of a millimeter. Like,
yeah, that step is key. Yeah, you first have to imagine that there's 0.6 millimeter of a bulge, and then everything will work.
Yeah, and then everything will work, or your ship sinks to the bottom of the ocean.
No, but you got a good point, which is, I believe he read they used a bubble level.
Yeah, it said they used a master level, whatever the hell that is.
Yeah, it's probably the brand of level that they used. Which, by the way, you can only level with the precision of your ability to hold it level, and your ability to judge the bubble between the lines.
Okay.
So they're just using local water techniques or liquid leveling techniques, and then they're just trying to make it parallel to the water surface. That's pretty much all they're doing.
Yeah, well,
what else could they do?
They think that parallel. They think that they're trying to quote unquote level it to the water surface, but in their model, level is curved. So they have to curve the rail so that the rail is one height above the water, and that it has to be, for some reason, 0.6 millimeters different in the center than at the edges, right? So it has to have a 0.6 millimeter curve over this distance, whatever the distance was.
Right.
I can actually, and that somehow if they didn't do this, it would work.
If you intentionally put a curve that's higher than the base with the water, it'd be arced in the center.
What's up, Dove?
Just trying to figure out why they would even do this. Like, what was the purpose? I really don't get it.
Like, if you have a 170-foot long piece of metal and you just go to the middle and jack the middle up, dude.
The tank is, so just to tell you, AI, the tank is 138 meters long and 3.5 meters deep, which corresponds to 3,000 cubic meters of fresh water. Despite appearances, the bottom of the tank is flat. And the maximum carriage speed was fixed at 12 meters per second, which is high for a facility of this size, but gives the ability to run a wide range of experiments. The dimensions were selected based upon the experience of university staff, past recommendations, and the site's physical limitations.
Yo, what are you talking about?
Yeah, we're talking about some corny-ass dude that came in here earlier saying...
Yeah.
So there's a tow tank, like it's a tank to model boats. It's like I was just describing its dimensions. And they claimed that they measured, that they had to account for curvature to make this tank because there was 0.6 millimeters of curvature higher in the center than at the edges on some rail. And the rail had to be exactly the same height above the water. So they took a string and then they measured, they pulled the string tight, and then they measured and adjusted this railing to make sure that it was curved exactly with the water. Just, it's a bunch of horse shit. Anyway, we had someone come in, we were just like laughing at it, basically, at this point.
Yeah. Well, it is a joke.
Well, it is a joke because his argument was it works, right? So their design of their tank to test boats, it worked. Like, what if you didn't account for 0.6 millimeters of curvature and 153 meter rail? What would the result have been? Like, you wouldn't be able to design boats anymore, and like your boat would sink to the bottom of the ocean now because you didn't like account for curvature in your little tow tank. Like, you're being dumb. Just shut up. You're embarrassing.
You know what's weird is the last guy who came in and argued that, which by the way we have recorded, and you guys could go watch that if you want. It was much more technical, but his argument, I believe, was that the sled or whatever that pulls the boat wouldn't be able to ride correctly on the rails if they weren't perfectly, in tune with the curve of the Earth, to the degree of like what, a 0.6 millimeter or 0.06 millimeter or some nonsense. Less than a credit card thickness, supposedly.
I'm reading like what was the justification for doing this. Like I can't find anything. Like
I just can't believe that people still in 2023 people still think we live on a spinning ball. It's just crazy to me.
Dude, it's worse than that, man. The last week, man, we had 3 people coming in. I think it's a ball because of the authorities. After what just happened with that Mexican beer germ, why you're trusting the authorities is beyond me.
And they call us, conspiracy theorists and nut jobs. And no, they're the nut jobs for, they're just brainwashed. Like zombies. Like the Night of the Living Dead.
Safety, man. They think there's safety in numbers, right?
Yeah.
So you ever seen the penguins in Australia? They like all huddle together, and like birds do the same thing when they flock. They all flock together because if they flock together, there's a probability you won't be the bird that gets eaten. It'll be some other bird. Because I've seen it, right? And, like where I live, there's pigeons that fly around in flocks. But when there's a hawk around, they go mad, but they stay in the flock. And you're the bird in the flock. You're hoping I'm not the pigeon that gets like snatched by the hawk. Some other bird that's right next to me. So that's kind of like a defense mechanism that they have, right? Stay in the herd, right? And they do it with antelope, elks, bulls, you name it. Go ahead, Joyce. Sorry.
It's all good.
Say, I've been listening on YouTube all morning. I couldn't get in here, but I tell you what, you'd be more productive just shitting your hands and clap than listen to dogs all day.
Yeah,
that's how I feel. I mean, thank you.
Yeah,
that's
I like listening to India though.
Man.
But the thing is, they're the conspiracy theorists. They're the ones saying like, you shouldn't believe your eyes. Like you see the sun moving, it's not moving. It's trying to fool you. It's actually you that's moving. Like the Earth looks flat. It's just the light is all trying to fool you. The world is all just out there, out to get you. It's actually a globe.
I really don't understand this tow tank argument because all that rail is doing is towing a model boat. What is that boat going to, not float on top of the water? Is it, what's going to be the
I don't under... Yeah,
oh
that's
my
what I'm trying to figure out by reading the document is why did they do this? Why did they go to all this effort? Because one way or another, it doesn't make any difference in what they're doing.
Dude, right now, brother, right now, check this out, friend. I specifically told him because I said they parallel this with the water. Did I not say that multiple times? He said the tank is empty when they do this. I told him they have a leveling trough that runs along the sidewall, and they use that to level against the rail. Okay? He said, oh no, I said, I know that we did that in the other one that we did, right? He said, well, I don't know about this one. Now keep in mind, this is something he posted as proof. So let's read from it right here. The tanks are fitted with a small trough in the concrete. This trough was filled with water. 2 steel pins were precisely machined. A datum bracket was installed at one end of the tank to adjust the length of the pins, so their pointy end just broke the surface tension of the water. Another bracket was then moved along the tank to the desired alignment location. Each pin was checked and readjusted.
Was the curve, did I get it wrong, but was it like 0.6 of a millimeter?
No, let me pay attention. Pay attention. You ready? I'll read it for you. The rails must be aligned vertically to follow the curvature of the Earth, horizontally and in roll. In Southampton, the Saginaw for an east to west oriented tank of 138 meters is about 0.06 millimeters. That's an assertion based on the model. It's not a measurement that they did. Or
oh, it gets better, AI. Read farther. Dude, this is hilarious. Listen to this, though. Sorry. The towing tank only has a walkway on its south side, so the north rail alignment had to be performed from a floating pontoon, which was complicated. Dude, I can't believe this.
I don't know. Anybody who works with steel would probably be able to tell you that, 0.06 of a millimeter was
over 153 meters, right?
Over
That's the span, right?
Meters. That's like their tolerances are higher than that.
Dude, that is a higher tolerance than CERN, probably.
Dude, look at this photograph of the pin system at the brackets. Look what they're doing there, bro. If you're looking, it's the brackets with the red thing and the 2-pin system. So the 2 brackets are at the joints of the thing, right? And so when those pins touch the water, they break the surface tension of the water. That means that the distance from that bracket down is correct. So they are just paralleling it to the water. Exactly like I said. What else could they do? How else could they have 100 and plus meter continuous level unless it was a trough of water? They also said in here that they couldn't use lasers to do it.
Yeah, I'm going to read that citation too. I'm going to find that. They cited something about them making a different tank in Australia. I want to know why they think they can't use lasers to do it. And now there could be reasons, right? Legitimate reasons, like inside. Sometimes you have differential heating inside of a building and stuff that will throw it off. Yeah. If you're trying to do a long span, I mean, you guys you do it incrementally, like you do in regular construction, right? You do, right? I don't know. I have to read it. My God, dude. This is what passed us for a Glober citation. I swear to God, that dude was just Googling furiously. The most frustrating part is that he didn't understand what, when I was predictive model, I'm talking about not Snell's law, not Fermat's principle, an actual model for terrestrial refraction as a phenomena, right? Not like the general rule of refraction, right? That model, generalized refraction model versus a model applied to a specific phenomena. Like that shit was going over his head, man.
They just try to talk big so that they sound important and they know what they're talking about. And then, as Miggy would say, they get their wig snatched. They like to repeat. But not
that must have been frustrating to listen to, from your point of view, right? When you're in it, it's a different thing. Dude.
I just want to get in there and tell him what a fool he is. That's all. I've had some experiences with this guy before, as well as heard a fair few debates that he's had, and I just can't stand him, to be honest.
Yeah, his debate techniques are transparent, dude. Whenever he gets cornered, he starts talking about you or talking about flat earthers or start calling you dumb, right? So he just does this all the time. Or he postures and pretends like you don't know something and he did, or you're freaking but it's a pretend, it's a freaking ruse, right? It's a diversion, right? To take eyes off the topic. Look over here. No, look over here. Look over here. Just don't how long did I talk to him? I never got an admission that there's no predictive model. I had to go through every goddamn iteration, right? Of just I call it